In the deepest laboratories on Earth, scientists have uncovered a discovery so profound it shatters every rule we believed governed reality. It's not a theory or a concept. These are real, observable phenomena. Particles that remember the future. Information that defies time, traveling backward. Objects that exist in multiple places at once, only to choose a singular location when observed. This isn't the stuff of science fiction nightmares. It's quantum reality, and it's more disturbing than anything we could have imagined. We're about to embark on a journey through 26 of the most mind-bending, reality-defying puzzles in physics, where consciousness might actually create the universe itself, where decisions made in the future can rewrite history, and where the simple act of observation tears open the very fabric of logic itself. Are you ready to have your mind shattered by the unimaginable? To have your understanding of everything, time, space, existence itself, flipped on its head? Then hit that like button and let's dive in. Let's start with one of the most iconic paradoxes in all of quantum mechanics, the double-slit experiment. It begins with a simple setup. A photon of light approaches two narrow slits in a metal barrier. Common sense tells us the photon should pass through one slit or the other, like a marble rolling through a doorway. But quantum mechanics has other plans. What happens next will challenge everything you think you know. When scientists fire individual photons at the slits, something impossible occurs. The photon, this tiny packet of light, doesn't just go through one slit. It goes through both slits at the same time, as if it were in two places at once, and the result? An interference pattern appears on the screen behind the slits, like ripples in water colliding with one another. This pattern, bright and dark bands, can only form if the photon is behaving like a wave, not a particle. A wave that has somehow passed through both slits simultaneously. Now think about that. A single photon behaving like a wave, as if it took every possible path through the two slits. This, by all logic, shouldn't be possible. A particle can't be in two places at once, right? Yet there it is, proof in the form of a light pattern on the detector. But here comes the truly disturbing part. The moment the experimenters place a detector at one of the slits to catch the photon in the act, everything changes. The interference pattern vanishes. The photon, once a wave of possibilities, suddenly behaves like a normal particle, choosing just one slit. It's as if the photon knew it was being watched. It knew it was being observed and decided to stop its quantum trickery. This isn't just a quirky experiment. It's a window into something far deeper. The very fabric of reality itself seems to be conscious of our observation. And that's the terrifying part. If the photon's behavior can change, simply because it's being watched, what does that say about reality itself? Does the photon actually exist in both slits, and we're just forcing it to pick a reality when we measure it? Or does it only exist in one state, once we measure it? Could the very act of observation be creating reality, rather than just uncovering it? The implications extend beyond just this experiment. It opens a massive philosophical question. Does consciousness play a role in creating the universe? If particles change their behavior based on our observation, could it be that the entire universe is only real when we're looking at it? This is just the beginning. The implications of the double-slit experiment don't end with a simple mystery. Oh no. What we're dealing with is a window into the terrifying unknown. If the mere act of observing changes the outcome, what does that say about the very nature of reality? Let's take a step back and consider this. In everyday life, we assume that things exist whether we're looking at them or not. You walk into a room and there's a chair sitting there, waiting for you to sit in it. You don't need to observe it for it to be real. But in the quantum world, things are different. Think about this. The universe seems to play a cosmic game with us. It's almost like it's hiding in plain sight, only revealing itself when we force it to. Take a photon, for example. Before we measure it, it could be anywhere. It's a cloud of potentiality. It's not a definite particle with clear properties. It's a wave of probability, existing in a superposition of all possible states, just waiting for the observer to collapse it into a single reality. And this goes beyond photons. Everything, down to the very atoms that make up our bodies, exists in this strange, uncertain state. You, me, the chair you're sitting on, and the air around you, it all exists as a probability wave, a mix of possibilities, until we measure it. So what happens to the universe when nobody is looking? When the observer isn't around to collapse these probabilities? Does reality just stop? Does it wait for someone to look at it and force it into existence? Here's the chilling reality. Some physicists suggest that without observers, the universe might just be a series of undetermined potentials, sitting in quantum limbo. Not quite real, not quite unreal, just waiting. But as soon as we measure, as soon as we observe, the wave function collapses, and boom, our reality snaps into focus. This concept of quantum weirdness extends into something even more disturbing. The idea that the universe might know when we're looking, a concept so strange that it has left even the brightest minds scratching their heads. Imagine a world where, if you set up an experiment to measure light as a particle, light becomes a particle. If you measure it as a wave, it behaves as a wave. The universe seems to have a strange, preemptive knowledge of what experiment we are planning to conduct. It's as if the universe itself can read our intentions, even before we make them. And here's the kicker. It doesn't end with light. This same quantum trickery is at play with everything in the universe, from the smallest particles to the largest galaxies. The universe is not static. It is not a fixed reality. Instead, it's a fluid, ever-shifting mass of possibilities that choose a definite state only when observed. You may be thinking, this is impossible. How can the universe change based on my observation? But quantum mechanics offers a stunning and terrifying answer. The answer is found in something called wave function collapse. When we measure a quantum system, we collapse it from a superposition of all possible states into a single, definite outcome. This collapse is what brings reality into focus, but it raises an even darker question. If a wave function only collapses when observed, what does that say about our place in the universe? Are we somehow creating reality through the act of observation? The implications are vast. Some even suggest that our decisions, our choices, may not be as independent as we think. In the quantum realm, where the very nature of reality depends on observation, what if everything we do, every action we take, is part of a web of possibilities, just waiting to be collapsed into something real? Let that sink in. Our very reality, our universe, could be nothing more than a series of probabilities, constantly shifting and morphing until the moment we choose to look. It's as though the universe itself is holding its breath, waiting for us to finally measure it. But what if that moment never comes? We're just scratching the surface. The more we look into the quantum world, the more it begins to look like a dream, a fleeting thought, something that doesn't truly exist until we decide to observe it. What happens next will shatter what's left of your understanding of time and space. It's not just particles and photons playing tricks on us. The very fabric of light itself, something we've long considered a fundamental and predictable force, has its own identity crisis that shakes the core of reality. For centuries, scientists have debated whether light is a wave or a particle, but quantum mechanics reveals that light isn't just one or the other, it's both and neither, depending on how you choose to look at it. Let's go back in time. In the early 1600s, Isaac Newton proposed that light was made up of tiny particles. This explanation made sense. It fit neatly with the understanding that light travels in straight lines and casts sharp shadows, as if it were made of tiny, discrete packets. But the theory ran into trouble when scientists realized light could also bend around obstacles. something only waves should be able to do. If light could bend like water ripples, then it couldn't just be made of particles. Enter Thomas Young in the early 1800s with his famous double-slit experiment. When light passed through two slits, it created an interference pattern, something we only see when waves collide and interact with each other. Waves, not particles. This threw Newton's particle theory into disarray. Light, it seemed, could act like both a particle and a wave. But how could this be? For 2 centuries, physicists debated this mystery. Is light a wave? A particle? A combination of both? And then, in the 20th century, quantum mechanics arrived to answer the question. But the answer was even stranger than anyone had imagined. Quantum mechanics doesn't just say light is both a wave and a particle. It says light becomes whatever you want it to be. If you set up your experiment to measure light as a particle, it behaves like a particle. If you set it up to measure it as a wave, it behaves like a wave. But, and here's where it gets mind-bending, it doesn't even wait for you to measure it. Light somehow knows how you plan to observe it and adjusts its behavior accordingly. Imagine a chameleon that doesn't just change its color to match its surroundings, but changes to match surroundings that it hasn't even seen yet. It's like light is able to predict the future of its measurement. But how? What mechanism allows light to know which path to take before the experiment is even decided? This is no mere laboratory oddity. The quantum nature of light has profound implications that stretch far beyond the confines of an experiment. Every interaction between light and matter, from a photon hitting a mirror to the light that illuminates your world, involves this quantum shapeshifting. When you look at a red rose, the color red isn't a fixed property of the flower. It's the result of photons deciding whether to behave like particles or waves based on how your eyes are structured. It's as though the universe is constantly asking itself, "Who's watching? How should I behave?" It's as if light is playing a cosmic game of hide and seek, changing its form based on future observations that may or may not happen. But here's the kicker. Light doesn't just shift its form based on present measurements. It can make this decision based on measurements that are planned in the future. Think of it like a magician who can set up their trick to work perfectly, not just when you're looking, but in anticipation of what you will choose to look for. Light seems to have a cosmic foresight, an ability to anticipate how we will observe it, and it shapes itself to fit our expectations. This is no longer just a quirky experiment. This is something far more profound. Every time you observe something in the quantum world, you're participating in this grand cosmic dance. Your expectations, your future choices, are influencing the very fabric of reality. And yet, despite all this, we have no idea how it happens. The mechanics remain a mystery. There's no communication between you and the light. It just knows. Every attempt to catch light in the act of this transformation has failed. Scientists have tried measuring light with detectors that are so gentle, so non-invasive, that light should barely notice them. Yet the result is always the same. Light knows how to behave before the measurement happens. The mystery deepens as we consider the implications for our understanding of reality. If light can decide its identity based on decisions we haven't even made yet, then what does that mean for the world around us? Could the entire universe, every particle, every event, be governed by these strange, hidden rules of behavior, waiting for our gaze to bring it into focus? What's more terrifying, we've built our entire modern world on these principles. Lasers, solar panels, LEDs, all rely on this strange wave-particle duality of light, but we don't fully understand how it works. The world we've built, our technology, our understanding of the universe, rests on a quantum mystery that we can't explain. And what happens when we take this a step further? When we realize that not only light, but everything might be in this constant state of flux, waiting for us to observe it before it solidifies into the reality we know? This is just the beginning. The true nature of reality is far more terrifying, and what happens next will blow your mind. As if the paradoxes of quantum mechanics weren't unsettling enough, what if I told you that time itself might not flow in one direction, that the future could actually influence the past? It's a concept so mind-bending, so terrifying, it challenges the very foundations of reality. Welcome to the world of retrocausality, where the future doesn't just happen, it reaches backward through time, shaping the past. Imagine this: a photon, traveling through space, is split into two entangled particles. One particle heads toward a screen, where it will be measured as either a wave or a particle, depending on how the experiment is set up. The other particle is sent across vast distances, and its path is up for grabs. Here's the kicker: the future decisions made by the experimenters, decisions about how to measure the first photon, will retroactively determine what the first photon did during its journey. Let that sink in. The past of the photon isn't fixed. It's dependent on what we choose to measure in the future. In quantum mechanics, the past and the future are not separate. They are entwined in a way that defies every classical notion of time. What does this mean for cause and effect? According to the rules of our everyday experience, effects follow causes. The future is determined by what happens in the present, and the present is shaped by the past. But in the quantum world, the boundaries between cause and effect blur. Future decisions can influence past events, retroactively determining how particles behave. Here's the mind-warping part. Scientists have performed experiments where they deliberately delay their decision about how to measure entangled particles. And the results? The choices made in the future seem to reach back through time to affect the past behavior of the particles, altering their outcomes. It's as if the photon, which had already traveled millions of kilometers across space, was waiting for us to decide what it should do. And it wasn't just reacting in the present. It was responding to decisions we hadn't even made yet. Now, I know this sounds like something straight out of science fiction, but this is the reality of quantum physics. The future can influence the past. Information isn't just moving forward through time, it's flowing backward too. The implications are nothing short of catastrophic for our understanding of time itself. You might be thinking, wait, that can't be right. This would mean that time is completely reversible, that we can somehow go back and change the past. But hold on. This isn't about time travel in the traditional sense. It's not about going back to the past and rewriting history. It's about something far stranger. The future isn't just waiting for the past to catch up. The future is actively shaping what came before it. The past is mutable, depending on future actions and measurements. It's as if the entire universe is caught in a loop, one where events can reach backward and change their own origins. What happens when we start questioning everything we think we know about the flow of time? When we realize that the arrow of time is more like a suggestion, not a rule? But this isn't just some abstract theoretical idea. There are experiments that confirm it. These retrocausal effects have been observed in quantum systems, where the act of measurement, the decision to observe something, determines how it behaves in the past. And it gets even worse. The further we look into quantum mechanics, the more we realize that this retrocausality may extend beyond just tiny particles. Could it reach across the universe itself? This concept isn't just limited to experiments in labs. Some physicists suggest that retrocausality could explain some of the most fundamental aspects of the universe, like the cosmic microwave background radiation. What if our observations of ancient light from billions of years ago are affecting the past in ways we never imagined? What if the very act of observing distant stars and galaxies is altering the past of the universe, shaping the evolution of everything we know? But let's take it one step further. Could our observations of quantum phenomena in the present actually be influencing events in the distant past? Could the decisions we make today be reaching backward to shape the formation of galaxies, the birth of stars, or even the origin of life itself? Could we be responsible for creating the universe, not just by observing it, but by influencing its creation in a way that defies all logic? As disturbing as that thought may be, we can't ignore the evidence. The future is reaching back into the past, altering the quantum reality that we experience. But the implications are even darker than that. What if time, as we understand it, is just a mere illusion? What if the real structure of reality doesn't abide by the linear passage of time at all? This is the terrifying frontier of quantum mechanics, a place where time itself loses its grip, a place where the future has the power to rewrite the past, and where reality itself is shaped by forces beyond our comprehension. The question is, where does this lead? And how far does the rabbit hole go? We've seen how quantum mechanics has thrown every expectation we had about time, space, and reality out the window. But hold on, there's an even darker layer to all this. The notion that not just time, but causality itself, could be turned on its head. Let's dig deeper into a thought experiment proposed by one of the greatest minds in physics, John Wheeler. Wheeler's concept of a delayed choice experiment forces us to confront the deepest paradox of quantum mechanics. It's not just that the future can influence the past. Wheeler suggests that the very act of measurement could retroactively change how particles behaved before we even decided to measure them. Here's how it works. Picture a photon traveling toward a beam splitter, a device that gives it two possible paths to follow. But here's where Wheeler's vision takes a disturbing turn. What if the choice of whether to measure the photon as a particle or a wave didn't happen until after the photon had already passed through the beam splitter? In classical physics, the photon should have already chosen a path by the time it reaches the splitter. But in Wheeler's universe, the photon has no idea which path it will take until we choose to measure it, after it has already traveled through the system. In simple terms, the photon's fate, whether it acts like a particle or a wave, is not determined by its journey but by the future decision of how we choose to observe it. The past, it seems, is not set in stone. It can be rewritten by decisions we make in the present or future. This is not just a quirky observation, it's the heart of the quantum measurement problem. When Wheeler's delayed choice experiment was finally tested, the results were as mind-bending as he predicted. The photon, it turns out, didn't behave according to its past trajectory. Instead, its behavior was entirely dependent on the choice made by the experimenter long after it had passed through the system. Whether the photon acted like a wave or a particle, it was determined after its journey, retroactively rewriting its entire history. Imagine you're watching a movie, but this movie isn't like any movie you've seen before. You get to the final scene, and you can change how the movie ends based on your future decisions. You can decide what happens at the end, but when you do, the entire story reconfigures itself to match that choice. The plot rewrites itself, going backward in time to fit the new ending. That's what Wheeler's delayed choice experiment suggests, that the entire history of a quantum event could change based on the observer's future actions. This isn't just theoretical speculation. It has been confirmed in multiple experiments with photons, where the timing of the measurement altered the past behavior of light, showing that the act of observation has the power to alter what has already happened. This upends everything we thought we knew about the linear progression of cause and effect. Let that sink in. If the behavior of a photon can change based on a decision we make after it has already traveled through the system, then what does that say about the past? Could we, in some way, alter the course of history simply by changing how we choose to observe it? The implications are staggering. If quantum mechanics allows us to alter the past with future decisions, then what does that mean for the rest of the universe? Could events in the distant past, stars forming billions of years ago, galaxies colliding in the depths of space, have been influenced by decisions made in the present or future? But this is where things get even more twisted. Wheeler didn't just leave us with a new understanding of delayed choices in quantum mechanics. He gave us a glimpse into a world where reality is shaped by the very decisions we make, and where those decisions can reach backward through time to influence what was once thought to be fixed. This opens the door to the terrifying possibility that everything we perceive, everything we know, might not be as solid and inevitable as we believe. We might not be passive observers of a fixed universe. Instead, we could be active participants in a reality that is continuously rewritten based on our observations. Our choices, our measurements, have the power to shape the past in ways we never imagined. But wait, the worst is yet to come. Because what happens if we realize that this is just one layer of a much deeper truth? What happens when we uncover the full, horrifying scope of quantum mechanics and discover that time, causality, and even reality itself might be governed by forces beyond our control? The question isn't just what's next, it's can we even comprehend what comes next? So far, we've uncovered disturbing truths about time, causality, and observation. But brace yourself, because what we're about to discuss takes the terror to an unimaginable level. What if everything you think you know about reality is just one sliver of an infinite multiverse, where every choice, every measurement, every quantum event creates an entirely new branch of existence? Welcome to the many worlds interpretation of quantum mechanics. This theory suggests that every possible outcome of a quantum event doesn't just happen in one reality. No, instead, each possibility spawns its own parallel universe, creating an endless branching of realities that exists simultaneously. Imagine a tree that keeps splitting into more and more branches, each one representing a different version of reality. Every decision you make, no matter how small, creates a new branch of existence, one where you live out an alternate version of your life. And here's the chilling part. You are living in all of them. Right now, every version of you that could have made a different choice exists somewhere in this vast, expanding tree. You may have chosen to turn left at an intersection instead of right, but there's another version of you living in a world where you made the opposite choice. There's a universe where you never met your spouse, a universe where you took a different job, moved to a different city, or even never existed at all. Every possible outcome, every decision, every quantum event that could have played out differently is playing out in some parallel world. But this is not just some theoretical fantasy. This is the implication of quantum mechanics when it's stretched to its most terrifying extremes. If every quantum measurement splits reality into a new branch, then we're not just living in one universe. We're living in many, in an infinite number of universes, each one a version of you, experiencing a slightly different reality. What does that mean for your sense of identity? If every version of you is equally real, then which one is the true you? Are all the alternate versions of yourself equally valid, or is there one correct version? And if you can't access the others, how do you know that your reality is any more significant than the billions of others that exist in parallel? Now imagine this. As each quantum event takes place, each one creating a new version of reality, you're constantly being split into an ever-growing number of selves. There are infinite versions of you, and each version is living out a different set of circumstances, exploring different possibilities. Every choice you make, every thought you think, pushes you down one path while other versions of you explore different routes. The result is a multiverse, an endless cascade of parallel realities, each one just as real as the one you're currently experiencing. This isn't just some science fiction fantasy. Recent experiments in quantum physics have shown evidence that these parallel universes might not just be theoretical, they might be real, existing in ways that are just beyond our ability to measure. These worlds, these alternate realities, are born every time a quantum event takes place, every time a decision is made, every time a particle behaves in one way instead of another. Think of it like a vast, invisible network of realities, each one running parallel to your own. But the truly terrifying part? You can't access these other versions of yourself. You can't reach into these other worlds. You're trapped in your own version of reality, left with only the faintest echoes of the countless possibilities that could have been. Now, let's add a layer of existential horror to this. If these parallel universes exist, then what happens when we realize that we might not be the only version of ourselves? What if the choices we make, the lives we lead, don't actually matter in the grand scheme of things? In the grand expanse of the multiverse, every possible version of you is living out every possible outcome. And if all these realities are equally real, what does it mean to be you? What does it mean to make a choice? This idea, this cosmic terror, reaches its peak when we start to consider that the multiverse might not just be an abstract theory. It might be a horror, a vast infinite web of realities where every possibility is played out, but none are truly significant. A reality where every moment of your life, every decision you've made, is just one of an infinite set of possible outcomes. You're just one thread in a tapestry of existence, one version of yourself among a multiverse of endless variations. The deeper we delve into quantum mechanics, the more we come to realize that the universe we live in might be far stranger and more terrifying than we ever imagined. We're not just participants in a single linear reality. We're part of an infinite branching multiverse that stretches beyond the limits of our understanding. And as if that weren't enough, the implications of this theory stretch into our very understanding of life, death, and the afterlife. If there are infinite versions of you living out infinite lives in an endless number of universes, what happens when you die? Does your consciousness shift into another version of yourself, continuing to live out a different reality? Or do you cease to exist altogether, trapped in a universe where the you that you knew is no longer there? The horror of the many worlds interpretation is not just the knowledge that infinite versions of yourself exist. It's the realization that, in the grand scheme of the multiverse, you might just be a fleeting, insignificant version of yourself, living out one of an infinite number of lives, each as valid and real as the next. The universe, it seems, doesn't just stretch infinitely in space. It stretches infinitely in possibility. But we're still only scratching the surface. What if there's an even deeper, more terrifying truth hidden within these infinite realities? The mysteries we've uncovered so far are just the tip of the iceberg. If you thought quantum mechanics couldn't get any stranger, you're about to be proven wrong once again. Now we're diving into a phenomenon so bizarre, it makes the many worlds interpretation look almost tame. Welcome to the quantum Cheshire cat effect. In classic literature, the Cheshire cat is a mischievous creature, disappearing and leaving only its smile behind. But in the quantum realm, the Cheshire cat doesn't just leave its smile, it leaves its entire identity behind. And the consequences of this phenomenon are nothing short of terrifying. Imagine this: a particle, such as a neutron, is sent through an interferometer, a device that splits the particle's path into two distinct arms and then recombines them. In classical physics, you'd expect the neutron's properties, like its position and spin, to remain associated with the particle itself. But quantum mechanics laughs at this expectation. What physicists discovered is something far more disturbing. Under the right conditions, a particle's properties can separate from the particle itself. The particle can travel one path, while its magnetic properties, its very identity, travel a completely different one. Let that sink in. A particle can be in one location, while its intrinsic properties, things like its spin and magnetic moment, are in a completely different location, taking a completely different path. It's like your shadow walking around independently, while your body remains stationary. But in this case, it's not just your shadow. It's the very essence of what makes you you, your fundamental properties, traveling through space, while the particle itself remains in its original location. This is not just a theoretical curiosity. It's been observed in laboratories, where neutrons, electrons, and even photons have been shown to separate their properties and travel independently. This is no longer a particle, it's a quantum ghost, a non-entity whose very essence wanders through space while its physical form stays behind. And here's where it gets even stranger. This isn't some fluke or measurement error. It's real. These particles and their separated properties can be measured independently. Imagine a person whose body stays put while their thoughts, memories, and personality travel to a distant location, interacting with objects and leaving a trace behind, while the person's physical body remains frozen in place. This isn't science fiction, it's quantum reality. But what does this tell us about the very nature of identity? If the properties of a particle can separate from the particle itself, then what does it mean to be a particle in the first place? Are we truly discrete entities, or are we just the temporary convergence of separated phenomena that, under normal circumstances, happen to exist together? Could our sense of self be an illusion, with our thoughts, memories, and emotions separated from the physical bodies that we call our own? This quantum Cheshire cat effect shakes our understanding of reality to its core. If a particle can exist separately from its own properties, then the boundary between subject and attribute disappears. Objects, fundamental particles, atoms, even entire molecules, are not collections of fixed properties. They're temporary associations between separate phenomena that under certain circumstances can split apart. And the implications extend beyond individual particles. Some researchers are exploring whether this phenomenon could be applied to larger systems. Could entire molecules exist as ghosts, with their physical properties split between different locations? Could even macroscopic objects, like a car or a chair, exhibit quantum behavior, with their properties separated and traveling through space independently? This isn't just a theoretical question. We're now able to experiment with quantum Cheshire cats on increasingly large systems. Scientists have succeeded in creating superposition states in objects that contain hundreds of atoms. Some of these objects have even been manipulated in ways that show properties like spin, magnetic moment, and charge traveling independently, creating the illusion of a disembodied object. And the more we push this boundary, the closer we get to a terrifying realization. If this effect applies to larger systems, including humans, then our entire understanding of identity, existence, and consciousness could be flawed. What if consciousness itself is nothing more than a collection of quantum phenomena that, under the right conditions, can separate and travel independently? What if our thoughts, emotions, and memories are not tied to our physical bodies at all, but instead are quantum processes that exist independently, only converging temporarily to form what we think of as a unified sense of self? This brings us to the most horrifying question of all. If identity is just a temporary convergence of quantum processes, then what happens when those processes split apart? What happens to the essence of you when your quantum properties are separated, drifting through space, untethered from your physical body? Does the true you, the core of your being, exist at all when the physical form dissolves, leaving only a fleeting quantum signature behind? This quantum conundrum challenges the very foundation of what it means to be something. If particles can exist independently of their properties, if objects can exist as ghostly collections of separate phenomena, then what happens when the fabric of reality itself is stripped of its coherence? What happens to us when we realize that the boundaries between self and non-self might be nothing more than quantum illusions? These questions don't just remain in the realm of theory. They're questions we must confront as we push the boundaries of our understanding in the quantum world. The Cheshire cat might leave only its grin behind, but quantum mechanics could leave us questioning whether anything we perceive as real is truly solid at all. And we're not done yet. there's still one more quantum mystery that will completely upend everything we think we know about existence. We've explored quantum weirdness from many angles: light that knows how to behave before we measure it, particles that exist in multiple places at once, and identities that vanish and reappear. But the deepest terror of quantum mechanics lies not in the phenomena we've uncovered, but in the very nature of reality itself. If all these paradoxes are real, then we're left with a question that haunts the deepest corners of physics. Who is the ultimate observer? In quantum mechanics, observation doesn't just reveal reality, it creates it. The act of measurement forces particles to choose a specific state, collapsing the quantum wave function from an array of probabilities into one definite outcome. This means that the universe, as we know it, doesn't actually exist in a fixed state until someone, or something, looks at it. Until an observer interacts with the quantum system, the possibilities remain in a state of flux, floating between different versions of reality. But here's where it gets truly disturbing. If reality is brought into being through observation, then who or what is the observer? We could argue that it's humans, our conscious awareness, that brings the universe into focus. But what if consciousness is nothing more than a quantum phenomenon? If our brains are just complex networks of quantum processes, does that mean our awareness is also part of the quantum system, rather than separate from it? Does the universe require an external observer, one that is outside of the quantum system, to create the reality we perceive? These questions are not mere philosophical musings. They strike at the very foundation of physics. If quantum mechanics truly depends on the act of observation to create reality, then who or what is doing the observing at the deepest level of the universe? And when we push this question to its limit, we confront a terrifying paradox. If the observer must also be a quantum system, then who observes the observer? Imagine this. A particle's state collapses when it interacts with a measuring device. But that device itself is made of quantum particles, which must also collapse their wave functions when observed. So the question becomes, who observes the measuring device? This chain of dependencies doesn't have a clear endpoint. It goes on indefinitely, with each observer needing another observer to collapse their wave function. This leads to an infinite regress, a never-ending chain of quantum measurements, each one requiring a new observer, with no ultimate observer in sight. Think of it like an infinite tower of security cameras, each one watching the camera below it. But each camera needs to be watched by the camera above it to collapse its quantum state. The tower goes on forever, with no ultimate observer to ground it in any concrete reality. The chain seems to loop infinitely, with no starting point, no ending point, just an endless series of observations. This leads to a terrifying conclusion. If there's no ultimate observer, no one or no thing that's separate from the quantum system, it suggests that the universe itself might be an endless, self-referential system, forever trapped in a recursive loop of quantum measurements. In other words, the entire universe might be observing itself, with each quantum system being both the observer and the observed. There is no outside reality. There is only an infinite web of quantum systems interacting with each other, creating a reality that is constantly in flux. This self-referential system shatters the traditional boundaries between subject and object, observer and observed. It forces us to reconsider everything we know about existence itself. What if the very concept of reality is nothing more than a quantum feedback loop? What if the universe only exists because it is constantly being observed, constantly measuring and collapsing its wave functions? The very act of observation, it seems, is the glue that holds the universe together, but it's also what makes it fall apart. But the most terrifying part of all this is that there may not be a simple answer to the question of who the ultimate observer is. It's possible that the entire universe, time, space, and everything within it, is a self-contained quantum system that creates its own reality through endless cycles of observation. The universe might not be real in the way we think of it. Instead, it could be an ongoing process of quantum measurements, with no objective reality existing outside of our observations. If that's true, then everything we experience, every moment of our lives, every particle we observe, is nothing more than a temporary convergence of quantum probabilities, forced into reality by our act of measurement. But what happens when we ask the ultimate question? What happens when no one is observing? If the act of observation is what creates reality, then when we're not looking, when no conscious observer is present, does the universe cease to exist? Or does it remain in a state of quantum superposition, waiting for us to look again, to collapse the wave function and bring it back into focus? The terrifying possibility is that, when we're not observing, the universe might not be real at all. It could simply be an ocean of undetermined possibilities, waiting for someone to witness it and make it real once more. This brings us to the most unsettling idea in quantum mechanics. What if consciousness itself is what creates the entire universe? What if everything around us, the stars, the galaxies, the very particles we observe, exists only because we are looking at them? What if the universe is nothing more than a projection of our collective consciousness, constantly being shaped and reshaped by the act of observation? The implications are horrifying. If consciousness creates reality, then we are not merely observers of the universe. We are its creators, and everything we experience is a product of our perception. The universe, it seems, exists because we look at it. But what happens when we stop looking? What happens when we stop observing, when the last conscious observer is gone? The question isn't just about quantum mechanics anymore. It's about the very nature of existence itself. Up until now, we've explored mind-bending quantum phenomena that defy our understanding of space-time and causality. But what if the most unsettling aspect of quantum mechanics isn't the paradoxes we've already uncovered? It's the possibility that the very act of observation could determine not just the nature of reality, but the ultimate fate of the universe itself? At the heart of quantum mechanics lies something we've only begun to grasp: the wave function. It's a mathematical description of all the possible states a quantum system can exist in. But here's where things get weird. This wave function doesn't just describe potential outcomes. It is the system, existing in a state of probabilities until it is observed, at which point it collapses into a single, definite outcome. Now, imagine that the universe itself operates in a similar way. What if all of reality, the stars, galaxies, planets, even time and space, exists in a state of quantum superposition, where every possible state exists simultaneously, but none of it is real until someone observes it? This theory, known as the Copenhagen interpretation, proposes that the universe is in a constant state of probability, and only through observation does it take on a definite form. If this is true, then every moment of existence is a product of observation, a collapsing of infinite possibilities into one concrete reality. The universe we experience, the world we think of as fixed and objective, is, in essence, a temporary configuration of quantum probabilities, one that only becomes real because we are here to observe it. But this raises an existentially terrifying question. What happens when no one is left to observe? If the universe is entirely dependent on conscious observation, what happens when there are no more observers? When the last human is gone, when consciousness itself ceases to exist? The frightening possibility is that the universe would collapse back into a state of quantum superposition. Time and space, matter and energy, everything we know, might cease to exist in any definitive way, dissolving into a vast sea of unobserved possibilities. The universe, it seems, could be a house of cards, held up only by the presence of consciousness. Once we stop looking, once we stop measuring, the entire structure of reality could collapse into nothingness. But wait, this isn't just speculation. In quantum mechanics, the notion of wave function collapse has been observed in the laboratory. It's real. When a quantum system is observed, it moves from a state of superposition, where it exists in all possible states, into a single definite state. This process has been tested, verified, and proven in countless experiments. So if observation can collapse the wave function of a particle, could it also collapse the entire universe? The consequences of this idea are far-reaching. If the universe is sustained by observation, then reality itself might be nothing more than a fragile construct, one that depends on the constant presence of conscious beings to keep it intact. What happens when we stop looking? Could the universe as we know it cease to exist altogether? This isn't just a philosophical question, it's a question that lies at the heart of the measurement problem in quantum mechanics. If observation determines reality, then what happens when the observer is removed from the equation? Can the universe exist without us? Or is our observation the very thing that makes it real? But this dilemma grows even more terrifying when we consider the many worlds interpretation. According to this theory, when we make a quantum measurement, the universe doesn't collapse into one definite state. Instead, all possibilities split off into different realities, creating a multiverse of infinite parallel worlds, each one representing a different outcome. This means that every decision, every measurement, creates not just one reality, but many, each one existing in its own parallel universe. If the multiverse is real, then we aren't just witnessing one version of reality. We're living in only one of countless possible worlds, and each time we make a choice, we're splitting reality into more versions of ourselves. But here's the catch. Every quantum measurement splits the universe. Every time you make a decision, you're creating an entirely new reality. You're not just choosing one path. You're creating a new branch in the multiverse, and every version of you is living out a slightly different version of your life. Now, imagine what happens when we apply this to the fate of the universe. If the universe is constantly branching into new realities, then what happens when the ultimate observer, the one who determines the fate of all these branching worlds, is gone? Will the multiverse continue to expand, with infinite new branches being created with each passing moment? Or will the entire structure of existence collapse into nothingness, with every possible reality fading away into an endless sea of unmeasured possibilities? This terrifying scenario forces us to confront the nature of existence itself. If the universe depends on observation to maintain its reality, what happens when observation stops? Is there a cosmic threshold, a point where the multiverse stops branching, where the universe itself collapses into a final state of nothingness? The implications are beyond unsettling. It's as if we're living in a dream, and our consciousness is the only thing holding the dream together. What happens when we wake up? Does the universe continue, or does it unravel into a chaotic, unknowable void? These questions don't have simple answers. They challenge the very foundations of physics, philosophy, and our understanding of existence. Are we the creators of the universe, merely dreaming it into being with our observations? Or is the universe something that exists, independent of us, and we are just passive observers of a reality that exists whether we're looking or not? As we push further into the heart of quantum mechanics, we realize that the true nature of reality might be far stranger, far more fragile than we could ever have imagined. And the more we uncover, the more terrifying the questions become. The ultimate horror of quantum mechanics isn't just the possibility that the universe is an illusion. It's the terrifying thought that the illusion might disappear when we stop looking. We've ventured into a realm where time, reality, and even existence itself can be shaped by observation. But what if I told you that there's another layer of terror within quantum mechanics, one that stretches across the vastness of space and time and reaches back to unravel the very fabric of our understanding? What if the future can influence the past, and what we choose to measure not only determines the present, but retroactively alters the history of the universe itself? Enter the quantum eraser experiment, a concept so unsettling it challenges everything we think we know about causality and reality. This experiment takes us to the very heart of quantum strangeness, where information is not only preserved, it's manipulated across time, and even more disturbingly, the past is rewritten based on decisions made in the future. Let's break this down step by step. The quantum eraser experiment builds on the famous double-slit experiment, which we've already seen defy logic. In the double-slit experiment, particles like photons behave as both waves and particles, depending on whether they're being observed. But here's where it gets terrifying. In a quantum eraser setup, even if you decide to measure which slit the photon passed through, you can still erase that information after the photon has already passed through the slits. Wait, what? You can erase information about the photon's past? Yes, and it's not just a quirky side effect. The quantum eraser experiment reveals that depending on whether the information about the photon's path is available or erased, the photon's behavior changes, even after the photon has passed through the slits and reached the detector. This is where things become truly mind-boggling. In the standard double-slit experiment, the photon passes through both slits and interferes with itself, creating an interference pattern on the screen behind. But when you attempt to observe the photon's path, the interference pattern vanishes, and the photon behaves like a classical particle, passing through only one slit. Now, the quantum eraser adds a new twist. If you erase the path information, the interference pattern mysteriously reappears, as though the photon had never been observed in the first place. Even though the photon passed through the slits long before the decision to erase the information was made, the photon's behavior is retroactively changed. It's as if the act of observation is rewriting history itself. Imagine this like watching a crime being committed. You know the criminal's face, you've seen it on the security footage, but then, just before you make the evidence available to the police, you somehow erase that footage, and suddenly, it's as if the crime never happened. Not only does the criminal disappear, but the very evidence of the crime is wiped clean, retroactively. This is more than a simple thought experiment. In laboratory settings, scientists have successfully demonstrated the quantum eraser effect. Photons that were already decided to behave as particles are made to act like waves again, simply by erasing the information about their path. It's as if the information about their past actions was never even there to begin with. The photon's history isn't set. It's created by the choices we make in the present, including whether or not we choose to erase the past. But here's where the true cosmic horror of the quantum eraser hits home. What if this phenomenon isn't limited to photons? What if everything we perceive as the past, our memories, the history of the universe itself, is equally malleable? If decisions made in the future can alter events in the past at the quantum level, could they affect the very structure of reality? What if the universe itself is subject to this retroactive rewriting? Could the cosmos be in a constant state of flux, with the past constantly reshaped based on what we choose to measure in the present? Could the Big Bang itself, the beginning of everything we know, be subject to changes depending on future measurements and observations we make? This is not just a theoretical nightmare, it's an existential one. If time itself can be manipulated in this way, then where does that leave us? Are we just passive observers in a universe that only exists because we're looking at it? Or is the very concept of time itself an illusion, a construct that is continuously being rewritten as we make new observations and choices? As unsettling as it is, the quantum eraser experiment opens up the terrifying possibility that our future decisions don't just affect us. They reach back through time, rewriting events that have already happened, altering the course of history itself. But if that weren't enough to leave your mind reeling, there's an even darker implication of the quantum eraser. What happens to the concept of free will in a universe where the future can change the past? If we're capable of altering the past through our observations in the present, then can we truly say that we're in control of our own fate? Or are we just playing out a script written by the quantum forces that bind the fabric of reality? What if everything you've ever done, every choice, every decision, has already been written in the quantum wave function, only awaiting your observation to make it real? What if your entire life is just one of an infinite number of possibilities, all existing simultaneously, waiting to be collapsed into one definitive reality by your decisions? This brings us to the ultimate question. If the future can rewrite the past, and if our observations are what create reality itself, then who or what controls the ultimate observer? Are we just spectators in a reality that bends and shapes itself based on our gaze? Or is there something else watching us, something beyond our comprehension, that determines the very rules of the universe? The quantum eraser may have revealed the ultimate truth, that the past and future are not fixed, but are merely pieces of a cosmic puzzle that we, as conscious observers, can alter. And in this reality, where the future can alter the past, the boundaries of time, space, and free will vanish entirely. What happens when we finally realize that nothing, not even the universe itself, is set in stone? If you've managed to keep your sanity after all the horrors we've uncovered about the quantum world, brace yourself, because we're now venturing into the most disturbing concept of all, the end of time itself. What if, at the deepest level of quantum reality, the very flow of time is nothing but an illusion? We've explored how quantum mechanics has defied our understanding of causality, events that shouldn't be able to influence each other across space and time, acting as if they are connected in ways that are utterly impossible. But now, the question isn't just about the relationship between past and future. It's about the very existence of time. Could it be that time itself doesn't exist in the way we think? Quantum mechanics is notorious for erasing our most fundamental assumptions. It throws out our understanding of particles, light, and reality, forcing us to confront a universe that is both stranger and more terrifying than we could have ever imagined. But the most terrifying realization of all might be this: what if time, as we understand it, is just a cosmic illusion? Let's begin with the notion of causality. In classical physics, causality is the foundation of how we understand the universe. A cause leads to an effect. The past shapes the future. But quantum mechanics shatters this neat progression. Consider the notion of retrocausality, which we've touched on before. In a quantum system, it's entirely possible for the future to influence the past, where a decision made today could retroactively alter events that have already happened. But here's the real kicker. What if the future is not just influencing the past, it's actually determining the present? In the quantum world, things don't happen in a neat linear fashion. Instead, quantum events exist in a state of probabilities until observed. And the moment we measure or observe those events, they collapse into one definitive state. But why, in a universe where everything is based on probabilities, does reality appear to move in a linear, causally ordered way? Here's the ultimate paradox. Quantum mechanics seems to suggest that time itself doesn't flow the way we think it does. If our observations collapse possibilities into a single reality, does that mean that time is simply a product of our observations, created the moment we look at it? Is time an emergent property of consciousness itself, rather than a fundamental aspect of the universe? The equations of quantum mechanics are time-symmetric. This means they don't inherently distinguish between past and future. If you reverse the direction of time in these equations, they still work. Everything looks the same, whether you go forward in time or backward. But in our everyday experience, time clearly flows in one direction, from past to present to future. It's a one-way street, but quantum mechanics doesn't respect that flow. It doesn't care whether events happen in the past or future. It only cares about probabilities, possibilities, and the act of observation. This brings us to an existentially terrifying realization. What if time itself isn't real? What if time is just a way for us to make sense of the universe, a convenient construct that gives us the illusion of order in a world where everything is uncertain? Quantum mechanics suggests that, at the most fundamental level, time might be as illusory as the particles we think we understand. Now, let's extend this nightmare into the realm of cosmology. We've already seen how quantum mechanics breaks down our understanding of causality, and now it's time to confront the terrifying idea that time might not just be an illusion on the quantum scale. It could be an illusion on a cosmic scale as well. What if the universe itself has no inherent time? What if the Big Bang, the beginning of everything, wasn't a moment in time at all, but a quantum event that only appeared to be the start of time due to the way we perceive reality? In this view, the arrow of time doesn't exist in the way we experience it. Instead, what we perceive as the past, present, and future are merely different manifestations of quantum possibilities, continually interacting and collapsing into one another. In a sense, time could be a product of the way we, as conscious observers, experience the world, and outside of that perception, it might not even exist. But wait, this idea doesn't just break down our sense of time. It shatters the very idea of cause and effect. If time is merely an illusion, then what happens to the concept of causality? The idea that causes precede effects is the foundation of how we understand everything in the universe. But in a world where time is uncertain and events can influence each other in both directions, causality itself becomes fluid. Could it be that the universe doesn't have a clear linear progression of events? Could it be that time, like everything else in quantum mechanics, is simply a state of probabilities, an illusion that we impose onto the universe to make sense of it? This notion challenges the very fabric of physics. How can we continue to trust the laws of thermodynamics, the progression of entropy, and the flow of time itself, if time is, in reality, a construct of our own perception? If quantum mechanics suggests that past and future are intertwined, that one can influence the other, does that mean the universe is eternally stuck in a state of flux, unable to settle into a clear deterministic state? And if time can be manipulated this way, could it be that we, as conscious beings, play a central role in determining the flow of time itself? Could our decisions, the act of observation, be the key that shapes not just our present reality, but the very structure of time as we know it? As unsettling as that idea is, it brings us face to face with the final cosmic horror. What if our entire perception of reality is based on an illusion? What if time, space, and even the laws of physics are just convenient constructs, and the true nature of the universe is far stranger and far more terrifying than we could ever imagine? The quantum world doesn't care about our perception of time. It doesn't care about our rules of cause and effect. It doesn't even care about our understanding of reality. What quantum mechanics suggests is that the universe is far less predictable, far less structured, and far less real than we'd like to believe. And in this terrifying world, the future can influence the past, the present is shaped by observation, and time itself might be nothing more than a fleeting illusion, one that we can never truly escape. We've journeyed through the deepest horrors of quantum mechanics, uncovering paradoxes that defy time, causality, and even existence itself. But now, we face a final, unsettling question that looms larger than all others. Is reality itself real, or is it merely a construct of our observations? Up until now, we've explored a universe that behaves according to strange rules that allow particles to exist in multiple states, time to collapse backward, and even light to shape itself based on the future. But as we pull back the veil, we're forced to confront a terrifying realization. All of this quantum strangeness may be the very fabric of the universe itself. Reality, it seems, may not be fixed. Instead, it could be fluid, constantly shifting and evolving depending on our consciousness, our perceptions, and our measurements. This brings us to the heart of one of the most terrifying aspects of quantum theory. The universe is not objective. In classical physics, we assume that the universe operates independently of our perception. It's always there, whether we observe it or not. But quantum mechanics throws this assumption out the window. According to quantum theory, the act of observation is not just passive, it actively creates reality. The universe doesn't exist as a fixed objective entity, at least not in the way we've always imagined. Instead, reality itself is brought into existence by conscious observation. We've seen how particles exist in a state of superposition, in multiple states at once, until they are measured, at which point they collapse into one state. But it's not just particles. This concept extends to everything in the universe. The entire cosmos, from the tiniest particles to the largest galaxies, could be existing in a state of quantum probability, with every moment of reality being collapsed into existence by our act of measurement. This means that time, space, and the material world itself may not exist as solid, unchanging facts. They might be fluid, constantly reshaping themselves based on our perceptions and interactions with them. But here's the true horror. If reality depends on observation, then what happens when we stop looking? What happens when we, as conscious beings, stop measuring, stop observing? If the act of measurement collapses all possibilities into one reality, then without conscious observers, would the universe cease to exist? Could it simply dissolve into a sea of undetermined possibilities, waiting for someone to observe it again and bring it back into focus? This idea pushes us to the brink of an existential nightmare. The universe as we know it might not be real in the traditional sense. It could be a projection, one that exists only because we are here to witness it. Without us, the universe might be in a constant state of flux, an undetermined quantum mess that only resolves into solid reality when consciousness comes into play. But let's push this terrifying concept even further. If we are the ones creating reality through our observation, then we're left with a truly horrifying thought. Could we be the creators of the universe? Not just passive observers, but active participants in the creation of reality itself. This would mean that the universe, everything we know, everything we perceive, is a projection of our own consciousness. We would be living in a reality that exists only because we observe it. The stars, the planets, the galaxies, they exist because we choose to look at them, and they collapse into a fixed state when we measure them. If that's true, then what happens when we stop looking? If the universe is only real because we observe it, then could it be that we, our conscious minds, are the very force that creates everything around us? Every decision we make, every thought we have, could be shaping the very fabric of reality, collapsing the quantum possibilities into the universe we experience. But here's where the horror deepens. What happens when we die? If reality exists because we observe it, does that mean the universe will cease to exist the moment there are no more conscious observers? Is life, and the universe as we know it, nothing more than a temporary construct that will fade away when consciousness itself is no longer there to witness it? This brings us to the darkest possibility of all. What if reality is just a dream? What if everything we see, the stars, the planets, the people around us, are nothing more than projections of our consciousness, illusions that collapse into existence only when we are looking at them? And what happens when we stop looking, when our consciousness fades away? Does the universe simply vanish, returning to the quantum realm, waiting for another observer to bring it back to life? We've reached the edge of reason. The quantum world has already defied our understanding of space, time, and causality. And now, we are forced to confront the possibility that reality itself may be no more than a fragile illusion, a product of our observations, our measurements, and our consciousness. The universe as we know it might not be real at all. It could be a creation of our minds, constantly brought into existence, and just as easily dissipating when we're no longer there to perceive it. The true horror of quantum mechanics isn't just that the universe behaves strangely, it's that the universe might be strange by design. The very act of observation, the very act of consciousness, could be the force that shapes the cosmos itself. What if reality is a construct, a dream, and we are the dreamers, trapped in an illusion that can disappear at any moment? The most terrifying part is that we might never truly know the answer. Our consciousness could be the key to understanding the universe, but it might also be the very thing that keeps us trapped in an unending loop of illusion. And when we finally uncover the ultimate truth of quantum reality, it could be so mind-shattering that the universe, our entire existence, might unravel before our eyes. If you've managed to follow us so far, you're already on the edge of your seat. But hold on tight, because things are about to get even more unnerving. Now that we've explored the terrifying uncertainty of quantum mechanics, we have to face one final existential horror, one that forces us to ask, could the entire universe we perceive be a simulation? It's the ultimate question in both philosophy and physics. Is reality really what it seems, or is it an elaborate illusion, a simulation crafted by a higher intelligence? We've seen how quantum mechanics defies every classical expectation, where particles exist in multiple states at once, and where future decisions can affect past events. But what if this strangeness is the clue to a much darker reality? Consider the implications of the simulation hypothesis, a theory put forth by thinkers like Nick Bostrom, who suggests that future civilizations might have the computational power to simulate entire universes, including the consciousness of beings that live within them. What if we are living in such a simulation, and everything we experience, our reality, the stars, the galaxies, the very laws of physics, is simply data projected by an artificial intelligence beyond our understanding? This isn't just a thought experiment. We now live in an age where we can simulate basic physical phenomena using computer programs. Think of how video games create entire worlds, how artificial intelligence generates real experiences, and how virtual reality blurs the lines between real and imagined. As technology advances, we're starting to realize that it might be possible to simulate entire worlds, worlds that feel indistinguishable from reality. Could we be inside such a simulation, one so sophisticated that we can't tell the difference? Now, let's add the quantum perspective. In quantum mechanics, particles don't exist in a definite state until they're observed. They only collapse into a singular observable reality once conscious interaction occurs. What if this collapse is not the result of a real universe, but of a universe that's simply being calculated as we observe it? Could it be that the universe is a massive cosmic computer running algorithms to process our existence, with consciousness being the program that runs the simulation? Every thought, every decision, every quantum measurement might not be real. It could just be the result of an enormous, complex calculation. Here's where it gets truly chilling. If we are in a simulation, then the laws of physics, the constants that we believe govern the universe, might be nothing more than the rules of the simulation. The speed of light, the force of gravity, the behavior of particles, these aren't universal truths. They are arbitrary parameters set by the creators of the simulation. What if, at any given moment, the program could change these constants, breaking the very fabric of reality as we know it? What's more, quantum mechanics seems to provide the perfect framework for a simulation. After all, the idea that reality only solidifies upon observation aligns with the way a computer simulation functions. In a simulation, only the parts of the world that are being rendered need to be computed in real time. The rest of the universe exists only in potential, ready to unfold when we engage with it. The quantum phenomenon of superposition, where particles exist in multiple states at once, could be analogous to the state of a simulation before it's fully rendered. When you interact with the world, when you measure the universe, it is rendered into the experience you're having. In other words, you could be the observer creating the simulation as you go along. But this doesn't just raise technical questions, it raises philosophical ones. If we're living in a simulation, then what does that mean about our existence? If our entire universe is an artificial construct, does that diminish the meaning of our lives? Are we just lines of code, existing for the amusement or purpose of a higher intelligence? Could everything we've ever known, from our consciousness to our experiences, be nothing more than the result of complex programming, created and controlled by entities far beyond our comprehension? We've seen the paradoxes of quantum mechanics that suggest the boundaries between observation and reality are incredibly blurred. Now imagine if these paradoxes extend beyond quantum particles to the very structure of the universe. If the universe is a simulation, then it might not be bound by the rules we think govern reality. The future could influence the past could be rewritten, and the very fabric of time and space could be altered at will by whoever, or whatever, runs the simulation. This also brings us back to the nature of consciousness itself. If we are in a simulation, where does consciousness come from? Is it an emergent property of a complex computer system, or is it something that exists beyond the boundaries of the simulation? Could the simulation be so sophisticated that it generates its own consciousness, or is there an intelligence behind the code that is aware of us? The chilling possibility here is that if we're in a simulation, our consciousness could be as artificial as the reality around us. But the most terrifying aspect of the simulation hypothesis isn't the idea that we could be living in an artificial universe. It's the question of who or what is running the simulation. If our reality is just data, then who or what decides what that data means? What if we're just one of countless simulations running in a larger, incomprehensible framework, and the reality we experience is just one of infinite possibilities being tested or run by beings far beyond our understanding? Is this some grand experiment? An infinite loop of creation and destruction, playing out across multiple simulations, with us as pawns in a cosmic game? What happens when we finally realize that reality itself may not be real at all? What if everything we've ever believed is nothing more than an illusion, a highly advanced digital projection, created to make us believe we exist in a universe that is meaningful, but is actually a computer-generated mirage? Could the true nature of the universe be far more terrifying than we could ever imagine? The questions become endless, and so does the horror. If we're in a simulation, how do we know there isn't another simulation inside this one, or 1,000 more simulations stacked on top of each other? Could the very nature of our reality be an endless series of nested simulations, each one unaware of the others, each one more fragile and illusory than the last? We might think we're close to the truth, but the truth is a terrifying black hole, pulling us deeper into uncertainty. And once we realize that everything around us might be a simulation, the boundaries between reality and illusion collapse. What happens when we finally realize that nothing is real? The nightmare isn't just about the quantum paradoxes or the strange behavior of particles. It's that we might not be real either. As we've explored the quantum realm, we've unraveled one terrifying mystery after another. We've seen how time and space lose their solidity, how reality is shaped by observation, and how the universe itself may be nothing more than a fragile simulation or a quantum construct. But now, we're confronted with an even more disturbing question, a question that threatens the very foundation of reality itself. Who, or what, is the ultimate observer? At the heart of quantum mechanics is the concept of observation. the idea that the act of measurement collapses a quantum system from a state of superposition into one definite state. We've seen how this applies to particles, photons, and even entire cosmic events. But if observation is the key to bringing reality into focus, then who is the observer that collapses the universe itself? What happens when we ask, who watches the watcher? You might think the answer is simple. It's us. We are the conscious beings that observe the universe and give it form. But this answer quickly unravels. If we're the observers, then who observes us? If consciousness itself is a product of quantum mechanics, then is our consciousness merely another part of the quantum system, needing its own observer to collapse it into reality? This is where things get truly terrifying. The very act of observation seems to create reality, but if we are quantum systems too, if our minds, our thoughts, our very perceptions are shaped by quantum mechanics, then who or what observes us? If our consciousness is itself part of the quantum system, then it too requires an observer to collapse it into a definite state. And who or what observes that observer? Imagine a cosmic house of mirrors, where each mirror reflects not just a person, but another mirror, and each of those mirrors reflects yet another, creating an infinite loop. In this scenario, each observer is being observed by another observer ad infinitum. But this leads to an existential abyss. Where does it all end? Who or what is the ultimate observer that breaks this chain? If we accept that consciousness itself may be a quantum system that requires an observer, then we face an infinite regress, an unending chain of observers watching observers, each one collapsing reality into focus. This isn't just a philosophical conundrum. It's a fundamental breakdown of our understanding of what it means to be in the universe. If no observer is outside the quantum system, then reality itself becomes an infinite loop, a recursive cycle with no end in sight. And here's the most disturbing aspect. What if the ultimate observer is something beyond our comprehension? Could the observer be a non-physical entity, something that transcends the quantum world, an intelligence that exists outside of time, space, and matter? What if this ultimate observer is the very force that holds the universe together, creating and collapsing reality at will, without us ever being aware of it? Now consider the implications of this for our experience of free will. If we, as conscious beings, are trapped in this infinite chain of observation, then what does that say about our ability to make independent choices? Are we truly the ones creating our reality, or are we simply part of a larger cosmic observation process, our every thought and action determined by the quantum system in which we exist? This recursive chain of observation doesn't just threaten our sense of free will, it threatens our very understanding of who we are. If consciousness is part of the quantum system, then we are merely the product of a cosmic observation process that goes far beyond our understanding. We may think we are independent, autonomous beings, but in reality, we are trapped in an unending feedback loop of quantum measurements, with no way of knowing who or what is at the top of the hierarchy of observers. The horror deepens when we consider that this ultimate observer might not be a conscious being at all. Could the universe be a self-sustaining system, where quantum observations happen on their own, without any conscious agent guiding them? Could reality, as we know it, be an illusion created by a system that doesn't even need us to observe it? In this view, the universe might be operating on its own, independent of any conscious awareness. Nothing but a cosmic feedback loop that exists for its own sake. But here's the true terror. If the universe doesn't require conscious observers to exist, then what does that say about our role in the cosmos? If we're not necessary for the universe to function, are we merely bystanders in a reality that operates regardless of us? And if our observations are what create reality, then what happens when we stop observing? Does the universe simply collapse into nothingness, returning to a state of quantum chaos, waiting for the next observer to bring it back to life? This idea of a cosmic observer watching the watchers opens up terrifying possibilities. If there is no ultimate observer, then does reality even have meaning? Is the universe truly random, or is it just part of a grand, incomprehensible design, orchestrated by an observer we can never reach or understand? The infinite regress of observers brings us to a chilling conclusion. What if we are not the creators of our reality at all? What if our consciousness, our perception of the world, is simply part of an unending chain of observation that stretches back through the fabric of space and time with no true starting point? What if reality is just a cosmic dance of measurement and collapse, with no final purpose, no final observer, and no final truth? And if this infinite chain of observation has no end, then where does it all lead? What is the ultimate goal of this cosmic loop? Is there a point to it, or is reality simply a random cyclical process that repeats itself infinitely with no meaning or end in sight? These questions threaten to unravel everything we know about existence, leaving us staring into an abyss of uncertainty, trapped in an infinite loop of observation with no escape. The most terrifying possibility is that we may never know the answer. We may spend our lives trapped in a quantum web, forever seeking the ultimate observer, but never reaching it. The questions themselves may be the true horror, because the answers might be beyond our understanding, hidden in the depths of the cosmos, waiting for us to collapse them into reality. So far, we've ventured deep into the quantum unknown, confronting paradoxes and unraveling the very fabric of reality itself. But now, we must face the ultimate terror that comes with understanding the cosmos on the most fundamental level, the end of the universe. And what if the end isn't just a distant future event, but something built into the quantum structure of existence itself? We've learned that quantum mechanics doesn't care about our intuitive notions of space and time. We've learned that time is malleable, that the future can affect the past, and that reality itself is nothing but a fragile illusion dependent on observation. But here's the terrifying truth. All of this may be leading us to the inevitable destruction of the universe. The very idea of the end of the universe is chilling enough. Most of us imagine it in some catastrophic sense, some grand finale where stars burn out, galaxies collide, and the universe collapses into a dark, empty void. But quantum mechanics reveals something far worse. The universe might already be dying, quietly and imperceptibly, at the quantum level. Let's break this down. You've probably heard of the Big Freeze, the theory that the universe will eventually run out of energy, causing everything to slowly decay into a state of absolute entropy, where nothing can happen anymore. There's also the Big Crunch, where the universe might eventually collapse in on itself, squeezing everything back into a singularity. But quantum mechanics introduces a terrifying possibility that the universe itself might be in a state of constant, invisible decay, driven by forces we don't even fully understand yet. Consider the concept of quantum tunneling, a phenomenon that allows particles to pass through energy barriers that, according to classical physics, should be impenetrable. This phenomenon is responsible for everything from radioactive decay to the fusion reactions that power stars. But what if quantum tunneling doesn't just occur in isolated systems, but in the very fabric of space-time itself? What if, at a quantum level, space-time is constantly undergoing tunneling events that destroy the universe from within? We've already seen how time can become warped and bend in impossible ways. But imagine this. What if these quantum fluctuations are so deep that they're gradually eating away at the structure of the cosmos? What if the very space in which we exist is slowly tearing itself apart without us even noticing? This is where quantum mechanics collides with cosmology in the most horrifying way. At the quantum level, everything is in flux. Every particle, every wave, every moment of time is a potential reality that could collapse into something else. But what if this fluctuation doesn't just apply to particles? It applies to space-time itself. What if the universe is on the verge of a quantum collapse so deep that no amount of observation, no amount of measurement can save it? This theory is called vacuum decay, and it's one of the most disturbing implications of quantum theory. Essentially, vacuum decay suggests that our universe could exist in a false vacuum, a state that isn't the lowest possible energy state of the universe. If the universe is in a false vacuum, it could undergo a phase transition to a true vacuum state at any moment. And when this happens, it would create a bubble that expands at the speed of light, annihilating everything in its path. The truly terrifying part of vacuum decay is that we wouldn't even know it was happening until it was too late. This transition could occur at a quantum level, unnoticed by us, and before we even had a chance to react, our entire universe could be gone, replaced by a completely different set of physical laws, one where our concepts of time, space, and matter simply don't apply anymore. But it doesn't end there. The concept of vacuum decay raises another terrifying possibility, that our universe is already dying in ways we can't perceive. We might be living in the dying days of reality itself, unaware that the cosmic clock is ticking down, one quantum fluctuation at a time. But if quantum tunneling and vacuum decay weren't bad enough, there's another quantum phenomenon that could destroy the universe in the most horrific way imaginable: black holes. You're probably familiar with black holes as regions of space where gravity is so intense that nothing can escape, not even light. But quantum mechanics suggests that black holes might not be the cosmic dead ends we thought they were. Instead, they could be the ultimate instruments of universal destruction. According to some theories, black holes are capable of evaporating over time via a process known as Hawking radiation. This radiation slowly leaks away the mass of the black hole until it disappears entirely, leaving behind only a remnant of energy. But what if this process isn't limited to individual black holes? What if the entire universe, from the smallest particle to the largest galaxy, is slowly being devoured by a process akin to Hawking radiation? In this scenario, the universe could be on a path to complete annihilation, where every atom, every galaxy, every star is gradually eroded by quantum processes beyond our control. It would be a slow, inexorable decay, a creeping death that would take billions of years to unfold, but in the end, it would leave us with nothing but empty space. The most terrifying aspect of this universal decay is the idea that we might be powerless to stop it. If the universe is truly governed by quantum mechanics, then reality itself might be subject to laws that are far beyond our understanding. Time, space, and matter could all be in a constant state of flux, collapsing and reforming in ways we cannot predict or control. And in this quantum nightmare, the end of the universe might not be a dramatic, catastrophic event. It could be a quiet, invisible process, unfolding in ways we can't even see. But the horror doesn't stop there. If the universe is constantly undergoing quantum fluctuations, if the very fabric of space-time is in a state of constant decay, then what happens to us as observers? If everything we perceive as real is just a projection of our consciousness, then what happens when the universe collapses entirely? Will we simply cease to exist, our consciousness trapped in a never-ending quantum loop, doomed to watch reality fade away in slow motion? And this brings us to the final, most chilling question of all. If the universe is decaying from the inside out, then is it already too late? Are we living in the last days of a dying reality, where everything we know is slowly being erased by the quantum forces that govern it? If the universe is constantly in flux, constantly collapsing into different possibilities, then are we just the latest iteration of an endless cosmic cycle, doomed to repeat itself until the end of time? The quantum catastrophe is real, and the most terrifying part is that we may already be living in the end of everything. As we inch closer to understanding the universe's deepest, most unfathomable secrets, we are forced to confront the ultimate terror, the death of everything. But this death isn't the dramatic fiery explosion of a supernova or the slow collapse of stars into black holes. No, this death is far more insidious, far more inevitable. It's the slow, creeping fade of reality itself, the gradual unraveling of the very fabric of existence, piece by piece. Let's step back and revisit something we've already touched on, the true nature of quantum mechanics. We've seen how particles exist in multiple states at once, how the act of observation creates reality, and how time, space, and even cause and effect crumble in the quantum realm. But now, we must face the uncomfortable possibility that this quantum strangeness isn't just limited to small particles. It could be spreading outward, consuming the entire universe, slowly erasing the very structure of everything we know. Consider the phenomenon of quantum decoherence, a process that happens when a quantum system interacts with its environment. In simple terms, this interaction causes the quantum superposition, the state in which particles exist in multiple possible states at once, to collapse into a single reality. When this happens, the system loses its quantum characteristics, becoming more classical, more real. This process is essential for the way the macroscopic world functions, where we don't see things in multiple possible states. But what if decoherence is more than just a byproduct of quantum systems interacting with their environment? What if, on a cosmic scale, the entire universe is undergoing a form of decoherence, as its quantum superposition collapses into a single, inevitable future? What if the universe itself is losing its quantum possibilities, slowly settling into a fixed state of decay? If this idea sounds terrifying, it should, because in this scenario, the universe we know is in the process of losing its quantum flexibility. It's becoming more rigid, more predictable, and more dead. The quantum fluctuations that make our universe dynamic, alive with possibility, are fading, replaced by an inevitable entropy that we can't stop, no matter how much we observe or measure. Imagine a universe that is slowly freezing into a state of irreversible decay, one where the possibilities of life, of stars, of galaxies, all become set in stone. Over billions of years, the quantum fluctuations that once made the universe feel alive, filled with infinite potential, will fade into a singular, inevitable truth. The universe will eventually collapse into nothingness. But this doesn't just apply to the grand scale of the cosmos. It applies to us too. If we are part of this quantum system, then our very existence might be slipping away without us realizing it. The decay of the universe isn't just some far-off event. It's already happening. Every time we observe something, every time we collapse a quantum state, we might be contributing to the cosmic entropy. We could be the very agents that are slowly killing the reality we hold dear, making it more real and less flexible, more bound by classical rules and less capable of existing in multiple possibilities. What does this mean for the future of existence itself? If the universe is slowly decohering, if it is moving toward a state of frozen inevitability, then we might be living in the last moments of quantum possibility. The universe might already be on its deathbed, and we are merely watching it slowly slip into a final lifeless state. Every moment of consciousness, every act of observation, might be contributing to the collapse of everything into a singular, inevitable end. But here's where it gets even more terrifying. What if the end isn't just the death of the universe? It's the death of meaning itself? If quantum mechanics reveals anything, it's that reality is incredibly fragile. It exists only because we observe it, only because our consciousness shapes it into existence. But what happens when we stop observing? When we stop measuring? Does the universe simply disappear? Does it return to a quantum void, a place where nothing exists until someone looks at it again? This idea, that reality itself depends on observation, takes us to the very edge of existential horror. If reality is fragile, shaped only by our perception, then what happens when we stop looking? Does the universe unravel, returning to a state of infinite quantum possibility? Or does it simply fade into nothingness, like a dream that ends when you wake up? The death of the universe in this quantum sense isn't the dramatic explosion of stars or the collapse of space-time. It's the slow, inevitable fade of reality itself. As the quantum fluctuations disappear, as decoherence spreads across the universe, the infinite potential of existence will shrink down into a single, deterministic future, a future we can never escape. But here's the deepest terror of all. What if the collapse of the universe is the beginning of something even more terrifying? If the universe is collapsing into a singular state, if all of reality is being flattened into one definite outcome, what does that say about the nature of existence? Could it be that the universe is not just dying, it's being replaced? Could there be something worse than the end of everything? Something that awaits in the infinite quantum abyss? This terrifying question raises an unsettling possibility. The end of the universe might not be the end at all. What if the universe is not a singular event, but a loop, constantly collapsing and resetting itself in a never-ending cycle? Could the death of our universe be the birth of another, and the birth of that universe the death of a previous one? In the end, we might be left with a chilling conclusion. The universe may not die in a singular event. It may never truly die at all. The horror of quantum mechanics suggests that the end is not an event, but a process, an infinite recursive loop of birth, death, and rebirth, constantly unfolding and never truly ending. We might be stuck in an eternal cycle, trapped in the quantum decay of existence, doomed to live and die in a universe that is always on the verge of collapse. This is the ultimate horror. The death of the universe is just the beginning of an infinite, timeless regression. As we dig deeper into the fabric of the cosmos, we begin to face the terrifying realization that the universe itself may not be a single, linear event. Rather, it could be an eternal cycle, a loop that never ends, where the universe constantly dies and is reborn, only to die again forever. And with that realization, we're forced to confront a far more horrifying truth. Time itself may not be real in the way we think. Time, as we understand it, is supposed to be a straight line, an arrow that moves inexorably from the past, through the present, and into the future. It's the foundation of all we know, our lives, our decisions, our experiences. But quantum mechanics has already shown us that this simple view of time is just another illusion. The paradoxes we've explored so far, the bending of time, the collapse of future events into the present, the impossibility of cause and effect, suggest that time itself may not behave as we think it does. What if, instead of being a straight line, time is an endless loop? What if everything we've ever experienced, everything that's ever happened, will happen again, forever? Quantum mechanics hints at the possibility of retrocausality, where future events can influence past events, creating a loop where the past and future become indistinguishable and time becomes an endless repeating cycle. The implications are staggering. If time is a loop, then nothing is truly original. Every event, every moment, every life could be part of a grand cosmic repetition. Our entire universe, from the Big Bang to the end of time, could be a single unbroken cycle of existence, constantly restarting itself, playing out the same scenes, the same events, over and over again. We might be living in a universe that is always dying and always being reborn, endlessly repeating itself without end. Imagine that. All of human history, the rise and fall of civilizations, the stories of our lives, our births and deaths, could be playing out in an infinite loop. Each choice we make, each path we take, might already have been made countless times before, destined to repeat over and over. The meaning of our lives could be trapped in this loop, doomed to repeat eternally with no escape. This terrifying thought is rooted in the concept of time symmetry in quantum mechanics. According to this principle, the equations that govern the behavior of particles work just as well when run forward through time as they do when run backward. This symmetry hints that time might not be a one-way street at all. If time is truly reversible at the quantum level, then could our universe be locked in a cycle, where every event is both cause and effect, constantly looping back on itself over and over again? And it's not just particles that are affected by this loop, it's everything. If time is cyclical, then the very fabric of space-time could be repeating itself. Every galaxy, every star, every planet, every life form might be part of an infinite cycle of creation, decay, and rebirth. The Big Bang could just be one of countless explosions, each marking the beginning of a new universe, only for that universe to collapse back into a singularity and begin again. Each cycle of the universe could be identical to the last, or it could be slightly different, with small variations. But in the end, everything repeats. This means that the universe we live in, our home, our reality, is not a unique one-time event. It's just another iteration in an eternal cycle. Every moment we experience might be part of a never-ending sequence, like a movie on a loop, playing over and over again. Each time we experience something, our joy, our sorrow, our triumphs and failures, they could all be repetitions of the same events, forever trapped in the cycle of cosmic time. But here's the most disturbing question of all. If time is a loop, then what is the purpose of our lives? If everything we do is destined to repeat, if our choices are already written, then what does it mean to live? Are we just actors playing out the same roles in an endless cosmic drama with no true free will? Is the sense of progress, of moving forward through life, just an illusion, a trick of our perception, designed to make us feel like we're advancing in time when we're really stuck in a loop? This isn't just an abstract philosophical question. It's a deep existential nightmare. The knowledge that everything we do is part of a repeating cycle could strip us of our sense of meaning, of purpose, of free will. If every choice we make has already been made, if every event in our lives is part of a cosmic script, then does anything we do really matter? The weight of this question could be enough to drive anyone mad. It could strip the universe of its wonder, leaving us with a cold, mechanical view of existence. A world where everything is predetermined, where nothing is truly unique, and where we are merely players in a game with no end. And what happens when we finally realize the terrifying truth, that time isn't moving forward, but in a loop? Does our perception of reality shatter? Do we lose the will to keep going, knowing that nothing we do will ever truly change, that we're just trapped in an eternal cycle? Or do we accept it, surrender to the cosmic loop, and stop searching for meaning, knowing that our lives are just echoes in an infinite regression of time? This is the true horror of time itself, the realization that it may not be real in the way we understand it. Time isn't a straight path, but a winding loop that circles back on itself, trapping us in a cycle of eternal recurrence. And with that knowledge, we are forced to confront the question, what happens when we've seen the end and we know it will come again forever? As we continue to explore the horrifying truths of quantum mechanics, we are faced with a terrifying possibility. What if science itself, our greatest tool for understanding the universe, falls apart? What if, despite all our technological advancements, despite our endless pursuit of knowledge, we are staring into the abyss of our own ignorance, powerless to comprehend the true nature of existence? This is the crux of the quantum paradox, the idea that no matter how much we learn, we are constantly confronted with a wall of unresolvable mysteries. The deeper we dig into the fabric of reality, the more we realize that the universe isn't just strange, it's fundamentally unknowable. We've seen how quantum mechanics defies everything we thought we knew about the world. Particles exist in multiple states at once, the future influences the past, and the very nature of time itself is bending and warping in ways we can't fully understand. These aren't just theoretical oddities, they are the foundation of the universe, and the more we try to understand them, the more we realize that the universe might be too complex, too strange, and too bizarre to ever fully comprehend. Take, for example, the concept of quantum uncertainty. Heisenberg's uncertainty principle tells us that we cannot measure both the position and momentum of a particle with perfect accuracy. The more we try to measure one property, the less we can know about the other. This isn't just a limitation of our instruments, it's a fundamental property of nature itself. The universe is inherently uncertain, and this uncertainty permeates every aspect of reality. The more we try to know, the more we are faced with an infinite regress of questions, each one leading to more confusion and more ambiguity. But the true horror comes when we realize that this uncertainty isn't just limited to particles. It applies to everything. If the universe itself is uncertain, then our understanding of reality is forever doomed to be incomplete. Science, which has been our greatest tool for understanding the world, might be fundamentally incapable of solving the deepest mysteries of the cosmos. What if the very laws of physics, the equations that have governed our understanding of the universe for centuries, are themselves fundamentally flawed? What if, as quantum mechanics suggests, the laws of the universe are not fixed, but dependent on observation and measurement? If the act of observation shapes reality itself, then the laws of physics could change depending on who is looking. This doesn't just undermine the idea of objective reality, it threatens the very foundations of science itself. We are living in a universe where our perception of reality shapes it, where the very act of measurement causes quantum states to collapse. But what happens when we realize that the universe is not what we think it is? That everything we've been taught, every theory, every equation, every law of physics, might be based on a flawed understanding of reality. If science can't even explain the nature of consciousness, if quantum mechanics defies logic, and if space-time itself is a malleable, flexible construct, then how can we ever be certain of anything? This is the existential terror at the heart of quantum mechanics, the realization that we might never know the true nature of reality. No matter how many discoveries we make, no matter how many experiments we conduct, there will always be a mystery beyond our reach. The universe is too vast, too complex, and too strange to ever fully unravel. We might be trapped in a cosmic maze, endlessly seeking answers that are forever beyond our grasp. The more we learn about quantum mechanics, the more we understand that reality itself is a riddle, a puzzle with no solution. And here's the most terrifying part. This riddle might be unsolvable. We might never be able to piece together the full picture of the universe, because the very nature of reality is fundamentally unknowable. It's as if the universe is a giant cosmic game where the rules are constantly changing, and we are left to play, never knowing if we're playing by the right rules at all. The implications of this are profound. If we are living in a universe where knowledge is constantly slipping through our fingers, where the more we try to understand, the more confused we become, then what is the point of science? What happens when we come to terms with the fact that science cannot provide all the answers? This is the horror of the quantum world. It's not that we don't know enough, it's that we may never know enough. Science might be on a path to an unknowable truth, one where the questions are infinite and the answers are forever out of reach. The more we explore, the more we realize that the universe is not something we can ever fully comprehend. It's a mystery beyond our understanding, and that mystery may be the true nature of existence itself. And what does that mean for us? If we are trapped in a universe we can never fully understand, then what is our place in it? Are we just tiny specks in a vast, unfathomable cosmos, trying to make sense of a reality that has no clear meaning or order? If the universe is fundamentally unknowable, then does our search for truth matter at all? Are we just wandering through a cosmic maze, chasing answers that will never come? This is the true horror of quantum mechanics, the realization that we may never understand the universe. The more we learn, the more we realize that the answers we seek are forever out of reach. Science, in its quest for knowledge, might be heading toward a terrifying conclusion. We are living in a reality that is beyond our comprehension. We've traveled deep into the quantum abyss, grappling with the terrifying implications of a universe that resists comprehension. But as we push further, we're forced to confront an even more disturbing reality. What if the very concept of certainty, of knowing what is true, is nothing more than an illusion? The very bedrock of our existence, the idea that there are fundamental truths and facts that define our world, might be crumbling beneath us. We've already seen how quantum mechanics tears apart our understanding of time, space, and causality. But now, we must face the most chilling possibility of all. What if everything we believe to be true is just a product of our perception? A narrative we've constructed to make sense of a world that is fundamentally unknowable? For centuries, we've relied on the scientific method to uncover the truth, believing that through observation, experimentation, and reasoning, we can pierce the veil of mystery and arrive at objective facts. But quantum mechanics tells us something far more disturbing. The universe is not what it seems, and the truths we hold dear may be far more malleable than we could ever have imagined. Take the Heisenberg uncertainty principle, for example. At the most fundamental level, we can never know both the exact position and momentum of a particle at the same time. This is not just a limitation of our measuring instruments, it's a fundamental property of nature. The more we try to observe and measure, the more uncertainty we create. In this strange world, knowledge itself becomes an act of uncertainty. The more we try to know, the more we realize that the universe is inherently unknowable. But this uncertainty isn't just about particles and subatomic processes. It extends to every aspect of reality. Quantum mechanics reveals that the act of observation itself affects the state of the system we're observing. In essence, the universe doesn't have a definite state until we look at it. This means that reality itself is shaped by our perception. What we think is real may not be objective truth. It might just be a reflection of our own consciousness, folding the universe into a form that we can understand. This realization leads us to a terrifying conclusion. Facts are no longer fixed. The very idea that there is a single objective reality is being dismantled. The universe as we know it might be an illusion, an ongoing process of observation and collapse, where facts are continuously created and destroyed by the act of measurement. In the quantum world, there is no absolute truth, only endless possibilities, constantly shifting and evolving based on our perceptions. Consider the famous double-slit experiment, where particles behave as both waves and particles depending on whether or not they are observed. In a classical world, you would expect the particle to behave in one way or the other, but quantum mechanics tells us that the particle exists in both states simultaneously until it is observed. In essence, the act of observation itself decides the outcome, collapsing the particle's wave function into one state or the other. This means that, at the most fundamental level, reality is not a set of objective facts, but a constantly unfolding story shaped by the observer. If this is true, then the most basic assumption we've made about the world, that facts are fixed, that truth exists independently of our perception, begins to crumble. We live in a world where truth is not an absolute, but a negotiation between the observer and the observed. Every measurement, every act of perception, creates a new version of reality, one that is only true for the observer in that moment. What is true for you may not be true for someone else, and what is true in one moment may not be true in the next. The implications of this are profound. If facts are not fixed, then how can we ever be sure of anything? How can we trust our understanding of the world when the very nature of reality seems to shift and change with every observation? And if reality is constantly in flux, how can we trust anything? Our memories, our experiences, even our own perception of the present? This is the horror of quantum mechanics, the death of certainty. The universe is not a static, knowable place. It is a dynamic, fluid process, constantly shaped by the act of observation. The facts we cling to, the truths we hold dear, may be no more real than the dreams we have at night. They are constructs, fragile and fleeting, disappearing as soon as we look away. And this uncertainty isn't just a philosophical dilemma, it's a practical nightmare. In a world where facts are no longer fixed, how do we build anything? How do we create meaning, establish goals, or make decisions when the foundation of reality itself is constantly shifting? If science is based on the assumption that facts are true and unchanging, then how do we even begin to trust the scientific discoveries we make? The very fabric of knowledge is called into question, leaving us with a terrifying void in place of the solid ground we once believed we stood on. But perhaps the most terrifying aspect of this uncertainty is not that we cannot know the truth, it's that we may never know the truth. If reality is constantly changing, if it is always being shaped by our observation, then is there any such thing as ultimate knowledge? Or are we doomed to live in a world where we are always grasping at shadows, chasing truths that constantly slip through our fingers? This brings us to the final, most horrifying conclusion. What if the universe itself is a lie? What if everything we experience, everything we know, is just a product of our own minds, projecting meaning onto a world that has no inherent structure, no inherent truth? What if the entire cosmos is nothing more than a grand illusion, a story we tell ourselves to make sense of the chaos around us? In the end, we must ask, can we trust science at all? Or has science, in its pursuit of knowledge, simply created another illusion, a structure built on fragile assumptions, constantly shifting and collapsing with every observation? The more we learn, the more we realize that certainty is a dream and the universe is nothing more than a shadow on the wall of reality. As we venture deeper into the unknown, we are confronted with an undeniable reality. The universe is not just a place of strange phenomena and unfathomable complexity. It's a riddle, a paradox that exists within itself. The very fact that we are able to study and measure the universe, that we can form questions and search for answers, may be the greatest paradox of all. What if the universe itself is the question and we are the answer? Let's pause for a moment and think about the implications of what we've uncovered so far. The universe isn't some neatly organized, comprehensible system governed by fixed laws. It is a labyrinth of uncertainty, constantly reshaped by observation, where the laws of physics break down at the smallest scales and time itself bends and distorts. We are living in a reality that defies our understanding, where the rules we've built our entire understanding of existence on seem to crumble under the weight of quantum paradoxes. At the heart of this confusion lies the idea that the universe might not be a thing at all. It might be a question, a puzzle with no definitive solution, forever teetering between possibility and impossibility. Quantum mechanics doesn't just bend our understanding of physics, it questions the very nature of existence. In the quantum realm, particles exist in multiple states at once, only deciding on a definitive reality when we look at them. This raises the most disturbing question of all. If reality is defined by our perception, then does the universe exist at all without us to observe it? The idea that the universe may exist only because we observe it is enough to make anyone question their place in it. If everything we know is shaped by our consciousness, then what happens when we stop looking? Could the universe, in its most fundamental form, be nothing but a projection of our own minds? Could reality be a fleeting, ephemeral thing that exists only when we focus our attention on it, only to dissolve when we turn away? This notion brings us to the most terrifying concept of all, the possibility that the universe itself is a lie. What if everything we know, the stars, the galaxies, the planets, and even the atoms within our bodies, is just an illusion, a fleeting image that exists only as long as we continue to observe it? Could it be that the entire universe, the vast infinite expanse of space and time, is nothing more than an endless series of fleeting quantum states, existing in a superposition of possibilities, and only collapsing into the reality we experience when we observe it? If this is true, then the most terrifying question of all arises. If the universe is just a projection, a quantum illusion, then what happens when we stop observing? What happens when there are no more conscious beings to witness the universe? Will it simply collapse into a void of nothingness, like a dream that fades away when we wake up? Or will it continue to exist, in some form we cannot comprehend, beyond the reach of consciousness, beyond the boundaries of time and space? This leads us to a horrifying paradox. If the universe exists because we observe it, then what is the role of the observer? Are we simply passive witnesses to a cosmic performance, or do we play a much more active role in shaping reality itself? If we are the ones defining the universe through our observation, then who are we really? What does it mean to be conscious in a universe that may not even exist without us to give it form? Are we the creators of the universe, or are we merely its products, trapped in a feedback loop that perpetuates itself, forever cycling between perception and reality? And as we stare into this abyss, we are forced to ask, is the universe truly infinite, or is it finite, bound by the limits of our perception? If everything is defined by observation, then perhaps the universe is not as vast as we think. Perhaps it is as small as our minds can conceive, limited by the boundaries of our consciousness. If the universe is an illusion, then its infinity might be nothing more than a reflection of our own imaginations, an endless dream that stretches out before us, with no true destination. But there's an even darker possibility. What if the universe is not just a question, but a mistake? What if reality itself is a glitch in the cosmic system, a random accident that led to the formation of stars, galaxies, and life? If quantum mechanics is right, and if the universe is constantly fluctuating between different possibilities, then perhaps our entire existence is just a momentary aberration, a tiny blip in an endless sea of probabilities. In this case, our lives, our experiences, everything we know, might be nothing but a temporary accident that will eventually fade away, replaced by something else, something we cannot even begin to comprehend. But here's the final, most terrifying thought. What if we are not the only ones observing the universe? What if there are other, unseen forces, other observers, perhaps beings beyond our comprehension, who are shaping reality alongside us? Could the universe be a playground for multiple observers, each one shaping their own version of reality, colliding with one another in ways we can't perceive? Could our own perception of reality be a mere fragment of a much larger, more complex cosmic drama that we cannot even begin to understand? The universe may not just be a question, it may be a paradox that has no answer, no solution, no resolution. And as we continue to explore the quantum world, we must confront the horrifying possibility that the true nature of reality is beyond us. We are left staring into the void, caught between the possibility and the impossibility, questioning everything we know and wondering if the answers we seek will ever be found. But here's the most chilling truth of all. The more we learn, the more we realize that the universe is not just a puzzle. It is the ultimate paradox, a mystery that may never be solved. We've uncovered the hidden strangeness of quantum mechanics, the paradoxes that unravel our understanding of reality. But as we look deeper, we're forced to confront another terrifying idea. What if everything is connected? What if the fabric of the universe is not just a series of isolated particles, but a vast interconnected web where every action, every thought, every event ripples through the cosmos in ways we cannot even begin to comprehend? At first glance, the universe might seem like a collection of independent systems, galaxies, stars, planets, and particles, all existing separately from one another. But quantum mechanics has already shown us that this separation is an illusion. Particles are not isolated, they are entangled, woven together in ways that defy classical understanding. Every particle, every object, every event is linked to every other, creating a vast network of interconnections that transcends space and time. Consider the phenomenon of quantum entanglement, two particles that become linked in such a way that their properties are intertwined, regardless of the distance between them. When one particle is measured, the other instantaneously reflects the same change, even if it's light years away. Einstein called it spooky action at a distance, but the truth is far more disturbing. This entanglement means that everything is connected across vast distances in ways we cannot see or understand. Every particle in the universe could be linked to every other, like threads in a cosmic tapestry, creating a web of connections that holds everything together. But the implications of this interconnectedness are far darker than we might expect. If every particle is entangled with every other, then nothing is truly separate. The boundaries we've constructed between ourselves and the universe are illusions. Every action we take, every thought we have, might ripple through the cosmos, affecting everything in ways we cannot perceive. The idea that we are isolated individuals is shattered, and we are forced to confront the terrifying possibility that we are not alone in our experience of reality. The most chilling aspect of this interconnectedness is that it suggests a level of vulnerability we can't escape. If every particle is connected to every other, then every action we take might have far-reaching consequences, not just for us, but for the entire universe. Our thoughts, our decisions, could have impacts that extend far beyond our comprehension. A single moment of observation, a single measurement in the quantum world, could reverberate through the entire universe, changing the course of events in ways we can't predict. In a universe where everything is interconnected, there is no safe place. Every action, every choice, no matter how small, might send ripples across the cosmic web, affecting distant parts of the universe that we will never see. The very idea of free will, the belief that we can make independent choices, becomes a terrifying illusion. We are not isolated beings. We are part of a larger interconnected system, one where our choices are shaped by the entire universe, and the universe is shaped by us. Think about the implications of this for our own existence. If everything is connected, then our every thought and action is part of a vast, intricate network of cosmic influence. What we do today might not just affect the world around us. It could affect distant stars, distant galaxies, even the very fabric of space-time itself. In a universe where nothing is truly separate, there are no small actions. Everything we do, no matter how insignificant it seems, is a thread in the cosmic tapestry. But here's the most terrifying question of all. What if this interconnectedness is not just a cosmic feature, but a mechanism for control? If everything in the universe is entangled, then who or what is controlling the web? Are we the architects of this web, or are we simply puppets, our strings pulled by unseen forces, locked in a dance that we can't escape? What if the interconnectedness of the universe isn't just a result of quantum mechanics, but a force designed to keep us trapped in a never-ending cycle, unable to break free from the cosmic web that binds us all? This is the horror of the interconnected universe. The realization that nothing is isolated. Every event, every thought, every particle is part of a larger system, a web that stretches across space and time. And in this web, there is no escape. There are no boundaries, no separations, no safe places. We are all part of the same cosmic system, and every choice we make ripples through the universe, creating consequences we cannot predict, altering the very course of existence itself. The deeper we look into the nature of reality, the more we realize that the universe is not a series of independent systems. It is an intricate web, a network of connections that binds everything together in ways we can't fully comprehend. And in this web, there are no simple answers. There are no easy escapes. We are all connected, and the consequences of our actions stretch out far beyond our reach, into the darkest corners of the universe. This is the ultimate terror, the knowledge that everything we do is part of a cosmic web, and we can never truly know the full consequences of our actions. As we've journeyed through the deepest corners of quantum mechanics, cosmology, and the terrifying paradoxes of existence, one thought looms over us. What if everything we've discovered has one undeniable conclusion? What if, at the end of the day, the universe is heading toward a single, unalterable end, and that end is the ultimate collapse of everything we know? The universe is vast, seemingly infinite in scope. Yet, even the most seemingly eternal structures, stars, galaxies, black holes, are subject to decay, destruction, and inevitable entropy. The laws of physics themselves seem to guide everything towards a single endpoint, the heat-death of the universe. As the universe expands, galaxies drift apart, stars burn out, and black holes evaporate into nothingness. In a sense, the universe is heading toward an ending where no light, no life, no energy remains. A cold, dark, lifeless void stretching out into eternity. But what happens when we come to terms with the fact that the universe's end is already written? That the greatest forces in the cosmos are leading everything toward one inevitable conclusion, a time when nothing exists except for the ghostly remnants of a once vibrant cosmos? The sheer magnitude of this finality is enough to shatter anyone's sense of purpose. If the universe is bound to die, then what does it all mean? What is the point of existence, of striving, of building and discovering, if it's all heading towards oblivion? It's easy to imagine the universe as a grand experiment, unfolding in real time across billions of years. But when we realize that the experiment is doomed to fail, when we understand that the very laws of nature are leading everything toward decay and entropy, the excitement of discovery turns to despair. What's the point of building knowledge, of advancing civilization, when it's all temporary? We are like passengers on a doomed ship, sailing toward an unknown end, unsure whether we will even have time to understand the journey before it's over. Yet, even as we face this inevitable conclusion, a more disturbing realization arises. What if the universe's death isn't just a matter of natural processes? What if there's something more sinister at play, something that isn't just waiting for the universe to burn out, but actively accelerating its demise? This idea, though horrifying, is gaining traction as scientists explore the idea that the universe's end might be far more deliberate than we ever imagined. Consider the idea of dark energy, that mysterious force that is pushing the universe apart at an ever-accelerating rate. Dark energy's effects have been known for decades, but its true nature remains one of the biggest mysteries in modern science. What if dark energy is not just a passive force, but a driving mechanism toward the universe's destruction? What if it is acting with a purpose, slowly and quietly ensuring that the universe will never find balance, never reach a state of equilibrium? What if the universe's accelerating expansion isn't just the natural consequence of the Big Bang, but an active process, pushing everything toward an unimaginable final state, a state where nothing remains but pure entropy? The universe, in this sense, is not just a story of creation and evolution. It is a trap built into the very fabric of space-time, where every force, every particle, every law of physics is aligned toward one outcome, the end. And that end might not just be a random occurrence. It might be the result of a cosmic plan, a set of mechanisms working from the very beginning of time to ensure that everything will eventually fall apart. The terrifying question then becomes, if the universe is heading toward its inevitable death, are we, humanity, civilization, just a temporary blip in this vast, doomed experiment? We are insignificant in the grand scale of the cosmos, but what happens when we confront the reality that everything we've built, everything we've hoped for, could be wiped away in a fraction of a second by the forces of the universe itself? This isn't just a theoretical fear, it's a problem we must grapple with. How do we live, how do we build meaning in a universe that is destined to collapse? The answer isn't simple, because even as we realize that everything is temporary, the human spirit refuses to accept that truth. We fight against the inevitable because we want our lives to have meaning, to have purpose. But in a universe where entropy reigns supreme, where death is the end of all things, can we ever truly escape this crushing inevitability? It's easy to look at the universe's decay and see it as a sign of failure, an end with no hope, no redemption. But the more we understand about the cosmos, the more we realize that this process of decay is simply the nature of existence. Everything in the universe, from the smallest particles to the largest galaxies, is bound to eventually fall apart. It's not a question of if, it's a question of when. And when we truly understand that, we must face one final terrifying truth. We, too, are part of that process. Just as the stars burn out and the galaxies drift apart, so too will our civilization one day be lost to time. Our thoughts, our actions, our entire history will eventually be forgotten as the universe continues its march toward inevitable decay. The heat death of the universe is not just a scientific theory, it's a certainty. And as we stand on the edge of this vast cosmic abyss, we are forced to confront the horrifying question. What do we do when we realize that the universe's end is already written, and all we can do is wait? As we stand at the precipice of this ultimate cosmic truth, one chilling question reverberates through our minds. What happens when the universe reaches its end? What will remain when stars are no longer born, when galaxies fade away, and when even the black holes that devour all things eventually evaporate into nothingness? Will anything remain, or will everything, every atom, every moment, simply fade into eternal darkness? The fate of the universe after its final expansion is not a tale of distant stars burning out. It's far more terrifying. A universe forever silent, devoid of light and life, slipping into an eternal night. This is the universe's ultimate fate, a state where even the smallest fragments of energy are stretched too thin to sustain any form of life, thought, or activity. The heat death we've come to understand is not a violent explosion or a cataclysmic end. It is a slow, agonizing fade into nothingness, a universe running out of time. Imagine this future. The stars which have illuminated our night skies for billions of years are no longer forming. The fuel that once powered them has been depleted, and one by one, they burn out into cold, lifeless embers. The light that once danced across the cosmos is extinguished forever. As the stars die, the galaxies themselves will drift apart, each one becoming an isolated island in a dark and empty sea of space. And then there are the black holes, the monstrous remnants of collapsed stars. They will continue to consume everything around them for eons, but eventually, even these titans of the cosmos will fade. The last black hole, a final monument to cosmic power, will evaporate into nothingness. And in the absence of all structure, in the emptiness left behind, the universe will become a vast, cold expanse, without even the faintest whisper of light or warmth. This is the end of everything, a universe slowly suffocating in the vacuum of space. The most terrifying aspect of this fate is that it is inevitable. There is no force we can muster, no intervention we can devise to stop this final outcome. The laws of physics themselves ensure that the universe will reach this endpoint, where every particle, every quanta of energy is stretched so thin that no further work, no further action can occur. In this cold, desolate future, nothing will remain, no stars to look up to, no life to ponder existence, no observer to even ask the question, what comes next? The universe will become a cold, dark place, where even the most fleeting spark of energy is long gone. The very fabric of space-time will decay into nothingness. The most complex systems, stars, planets, life, consciousness, will no longer exist. The universe will have no purpose, no meaning, no life. But perhaps the most terrifying realization of all is that we, in our current age, are powerless to change this fate. We are helpless against the forces that guide the universe toward its inevitable death. All our technological advancements, our understanding of the cosmos, our dreams of escaping this fate, none of them will alter the course of time. The universe is not a place we can save or alter. It is a machine running toward its own death, and we are mere passengers on this doomed journey. And yet, as we face the end of everything, we must ask, is there a way to escape this fate? Can we find another universe, another dimension, or a higher plane of existence that will escape this slow, cold death? As much as we wish to avoid it, the answer remains elusive. Our best hope might lie in something far more profound than anything we currently understand, a force beyond our reach, beyond our comprehension. One potential idea is the concept of the multiverse, the theory that our universe is not the only one, but part of an infinite expanse of universes, each with its own set of laws and conditions. If this theory is true, then perhaps the end of our universe is not the end of all existence. Perhaps other universes are born, live, and die in an eternal cycle, independent of our own universe's slow fade into oblivion. If that is the case, then perhaps the future of existence lies in other realms, beyond the reach of our collapsing universe. But even the multiverse doesn't provide a comfortable answer. What if the end of our universe marks the end of all universes? What if every universe is doomed to this same fate, forever decaying into entropy until nothing remains? The chilling truth is that we might not be able to escape the ultimate end. Our universe, and any potential multiverse, could be bound by the same rules, leading to an inevitable conclusion, that everything, in the end, will fade away into eternal nothingness. And yet, despite the horror of this fate, there is something oddly comforting about the certainty of it. We can't change the end, but we can come to terms with it. This is the great paradox of existence. The universe might be heading toward an unalterable, inevitable death, but the very knowledge that we understand its fate gives us meaning. Perhaps our role is not to fight the inevitable end, but to embrace it, to appreciate the beauty of the moments we have before everything is gone. So what does it mean to live in a universe that is destined to die? Perhaps it means finding meaning in the fleeting moments we have. Perhaps it means cherishing our brief existence and embracing the knowledge that we are part of something much larger than ourselves. A grand cosmic dance that will one day come to an end, but that still burns brightly for now. The heat death of the universe is a cold, inevitable fate, but in the face of it we must ask, what will you do with your time, knowing that everything is doomed? The true horror lies not in the knowledge of the end, but in how we choose to live with it. And perhaps in that choice, we find our true meaning. As we stand at the threshold of cosmic oblivion, a final haunting question emerges. Who will witness the end of the universe? Who will be there to see the stars extinguish, to watch galaxies drift apart, to witness the quiet and undisturbed march of time as it leads everything to its final conclusion? The answer to this question is more terrifying than any other we've faced. Perhaps no one will be there at all. The universe in all its grandeur has existed for billions of years, unfolding in a dance of creation, destruction, and rebirth. We, as tiny specks on a pale blue dot, have spent a fraction of this time contemplating our place in the cosmos. But what happens when the universe finally reaches its end? Who will be left to look upon the empty, cold space that will be all that remains? What happens to meaning, to awareness, when there is no one left to experience it? As we've learned, the universe is on a one-way journey toward heat death, toward a state of ultimate decay, where energy is spread thin and no more work can be done. When the last star flickers out, when the last black hole evaporates, and when the final remnants of existence fade into the void, there will be no one left to witness it, no observer, no consciousness, just emptiness. This is the most haunting aspect of the universe's demise. The end will come, and it will come without an audience. No eyes will see the final moments. No ears will hear the last whispers of a universe that was once full of light, sound, and life. The cosmic drama will play out in complete isolation, with no one left to ask, what was it all for? No one left to observe the last collapse, the last quivering of existence. The universe's end will be, in every sense, silent. But what does this mean for us? For humanity, for life, for all the struggles we face day by day? We are creatures driven by a need for meaning, for purpose. We strive to understand the world around us, to seek knowledge, to create, to build, and to leave behind a legacy. But if the universe is destined to end in cold, unfeeling entropy, if all our efforts, all our dreams, will eventually be swallowed up by the void, what is the point of it all? This question, this eternal quest for meaning in a universe that will eventually collapse into nothingness, is something that has haunted philosophers, scientists, and thinkers for millennia. We are faced with a paradox. The very act of seeking meaning in a universe that will ultimately offer none seems in some ways futile. The stars we look up to, the stories we tell, the civilizations we build, they will all fade away, eventually forgotten, lost in time and space. Yet, despite the overwhelming certainty of the universe's decay, there is something inherently human in our desire to understand, to find meaning, and to continue existing even in the face of the inevitable. Perhaps the very pursuit of knowledge, the search for meaning, is the true purpose of existence. Even if the universe ends in silence, even if the last moment is observed by no one, the fact that we are able to look up at the stars and ask the big questions, that is what makes us truly alive. It's a paradoxical truth. In a universe where nothing truly matters in the end, the search for meaning becomes the only thing that does. It's not about the answers we find, but about the journey we take, the exploration we undertake in search of those answers. In a way, it's the act of questioning itself, the act of searching for truth, that gives life its fleeting spark. So, even though the universe is headed for an inevitable death, we are still given the opportunity to ask, to dream, to wonder. We have a brief window of time in which to experience the universe, to explore its wonders, to push the boundaries of our understanding. And in that short time, we have the chance to make our lives meaningful, not through the certainty of the answers we find, but in the pursuit of the questions. But as the universe moves toward its final moments, we can't ignore the uncomfortable truth. We are a part of a cosmic story that may never have an ending. The universe, in all its complexity and beauty, is like a book with no last page. As the heat death looms on the horizon, we are left with one final question. Will we be content with the story we've written, or will we be haunted by the fact that the book was never finished? There is an undeniable tragedy in the fact that the universe will reach its final moments, and there will be no one left to witness it. But that tragedy is tempered by the fact that we are here now, and in this fleeting moment, we have the opportunity to experience it all, to dream, to learn, to ask, to explore. Perhaps that is the greatest gift of all, to live with the knowledge that even in a universe that is dying, we are alive. As we stand on the brink of cosmic oblivion, one final haunting thought presses on our minds. What if the universe isn't just dying, but is already trying to communicate with us? What if, even as the stars fade and the galaxies drift apart, there are messages embedded in the very fabric of space and time, messages that we've yet to understand? We've explored the terrifying implications of quantum mechanics, the inevitable end of the universe, and the chilling idea that everything we know will eventually decay into nothingness. But what if there is something more to this end? What if the universe, in its final moments, holds the answers to the questions that have plagued humanity for centuries? Could there be a cosmic echo, a ripple through time and space that reaches back to us, offering a clue to a greater hidden truth? Imagine this. In the far distant future, when the universe has expanded beyond recognition, when every star has burned out and every black hole has evaporated, there remains a faint, lingering trace, a signal, a remnant, a faint whisper from the past. This signal, though nearly imperceptible, carries with it the key to understanding not only the fate of the universe, but the very nature of reality itself. And this message might be encoded in the cosmic microwave background, the faint radiation left over from the Big Bang. The CMB is like the universe's echo, a relic of its birth that still lingers in the background of space. Scientists have detected this ancient radiation, and while much of it is simply the remnant heat of a universe cooling after the Big Bang, there may be more to it than we realize. What if the CMB is not just an afterthought of creation, but a deliberate message embedded in the fabric of space-time itself, waiting to be decoded? What if this cosmic radiation holds the answer to the deepest mysteries of existence, including the very meaning of life and death? In a way, we're like cosmic detectives, standing on the precipice of oblivion, listening for a signal that might never come. We're searching for meaning in a universe that is on the brink of dying, trying to understand a message that could be waiting for us in the very structure of the cosmos. If there is a hidden message, then perhaps the universe itself is not just an object of study, but a living entity, a system that is attempting to communicate with us, even as it hurtles toward its end. But here's the terrifying twist. What if we're not the first civilization to have received this message? What if other intelligent beings in other galaxies have already decoded the signal and found the answers we're still searching for? The possibility of alien civilizations that have come before us, who have lived and died in the far reaches of space, is a sobering thought. What if their knowledge, their discoveries, their warnings, have already been encoded into the fabric of the universe, only for us to uncover after their extinction? And what if the message is not what we expect? What if it's not an answer at all, but a question, an existential riddle that challenges everything we know about life, the universe, and our place within it? Imagine discovering that the ultimate truth is not something we can understand with our current knowledge, but something beyond comprehension, an answer that can only be realized when we transcend the limitations of our physical and mental forms. The cosmic echo, in this sense, is not just a relic of the past. It is a message that speaks to the future, a warning, a challenge, or perhaps a call to a new form of existence. And yet, there is something deeply unsettling about this idea. What if the echo we're hearing is not from the distant future, but from a parallel reality, one where the universe didn't die, one where it evolved in a completely different way? Could we be listening to a reflection of what could have been, a shadow of an alternate universe that lives on while our own fades into nothing? The echo is more than just a signal. It is a reminder that we are part of a much larger cosmic story, a story that spans across not just time and space, but across potential realities, across parallel universes. And as we continue to search for meaning in a universe that seems to be running out of time, we must ask, are we hearing the echo of our own demise, or the whisper of a future yet to be written? Perhaps the most terrifying part of this cosmic riddle is that we may never have the chance to understand the message, to decode the signal that is embedded in the very structure of space-time. As the universe continues to expand, and as the stars continue to burn out, we may find that the message we've been searching for is slowly slipping away, lost in the void of an ever-expanding cosmos. The echo of the universe may be fading, its message fading with it, leaving us to wonder whether we will ever know the truth. But here's the most disturbing thought of all. What if the universe has already spoken, and we're simply too late to hear it? What if the message we've been waiting for was always right in front of us, and we missed it? The universe's final whisper might be nothing more than the silence we hear when the last star burns out, a quiet, inevitable end to a story that was never meant to have a conclusion. As we dive deeper into the mysteries of the universe, one unsettling realization emerges. What if time itself is not the constant we've always believed it to be? What if our understanding of time, with its neat progression from past to present to future, is nothing but a limited perspective? The universe, it seems, is far stranger than we ever imagined, and the very fabric of reality may hold secrets that challenge everything we know about existence. In the realm of quantum mechanics, time behaves in ways that defy our intuition. We've already seen how particles can exist in multiple states at once, how they can be entangled across vast distances, and how observation itself can collapse probabilities into definitive states. But what happens when we apply these principles to time itself? Can time too be manipulated? Can it be stretched, bent, or even transcended? At the heart of quantum theory lies a concept so mind-bending, it seems to defy all reason: the ability to move through time in a way that isn't linear. If time is not a constant, but a malleable dimension, then what does this mean for our understanding of causality? Could we, in theory, travel backward in time? Could we influence past events, or even change the course of history? For centuries, time travel was the stuff of science fiction, a tantalizing idea explored in books and movies. But now, scientists are beginning to entertain the possibility that it might not be so far-fetched. If quantum mechanics allows for particles to behave in ways that defy our understanding of space and time, then why not time travel? Perhaps the universe holds the key to traveling backward, or even forward, through time, not as a theoretical concept, but as a genuine possibility. To understand this, we must first explore the idea of quantum tunneling. We've discussed how particles can pass through barriers that classical physics says they should never be able to cross. But what if these barriers are not just physical walls, but temporal ones? Could particles, or even information, tunnel through time itself, bypassing the limitations of the present and reaching into the past or future? This is where things start to get truly strange. Imagine for a moment that time is not a straight line, but a vast, tangled web. Just as particles can exist in multiple locations at once, could events in time also occupy multiple points simultaneously? What if the past and the future are not fixed, but are instead fluid, shaped by the very act of observation? Could the future influence the past, just as we've seen with quantum entanglement? Could we, in some sense, reach into the past, pull the threads of history, and change the course of events? The idea of retrocausality, where future events can influence past ones, has been a controversial and unsettling topic in quantum physics. But recent experiments have shown that the future might have an actual, measurable effect on the past, as if time itself flows backward, breaking down the barriers between cause and effect. The implications of this are staggering. If we can influence the past through our actions in the present, then perhaps we have more control over our destiny than we ever imagined. But here's the real question. What happens when we transcend the linearity of time altogether? If we can influence the past and the future, could we move freely between the two? Could we leap from one point in time to another, leaving behind the constraints of our linear existence? And if time is not a constant, if it is fluid and malleable, what does that mean for our understanding of the universe itself? The idea of transcending time brings us to the concept of the multiverse. If multiple realities can exist simultaneously, then perhaps each timeline is just one thread in a vast, interconnected web of possibilities. What if we could travel between these timelines, experiencing alternate realities, exploring different versions of history, and even interacting with different versions of ourselves? This idea, though mind-bending, is gaining ground in theoretical physics, where some believe that time travel could be achieved by moving between parallel universes. The implications of this are profound. What would it mean for us, as conscious beings, to exist across multiple timelines, to experience different versions of reality? Could we choose which version of ourselves we want to be? Could we relive moments from our past, altering the decisions that shaped our lives? Would our actions in one timeline affect the others, creating a ripple effect that changes the course of multiple realities? The possibilities are limitless, and yet, so are the dangers. If time is not fixed, if we can move freely between past, present, and future, then the very fabric of reality becomes incredibly fragile. Every decision we make, every choice we take, could have consequences that reach across timelines, affecting not just our reality, but every possible version of it. And the more we try to manipulate time, the more we risk unraveling the very fabric of existence itself. Yet despite the dangers, the idea of transcending time is intoxicating. What would it be like to live without the constraints of time? To experience every moment, every possibility, without being bound by the rules of causality? To have the ability to leap between points in time, to explore the universe not just as a physical space, but as a fluid, ever-changing realm of potential? As we grapple with these questions, one thing becomes clear: time is not the enemy. It is the ultimate key, the key to understanding the universe, to unlocking the mysteries of existence, and to transcending the limitations of our physical forms. If we can master time, if we can bend it to our will, then perhaps we can unlock the true nature of reality itself. But even as we dream of such possibilities, we must remember that the ultimate power lies not in manipulating time, but in understanding it. The true terror of time travel is not the ability to change the past or the future, but the realization that time, in all its complexity, may be something we can never fully control. As we venture deeper into the cosmic mysteries that bind the universe together, one question continues to haunt us. What role does consciousness play in the grand scheme of existence? We've explored the mind-bending realities of quantum mechanics, the unstoppable expansion of the universe, and the ultimate fate that awaits us all. Yet, despite all our discoveries, there is still one fundamental enigma that remains unsolved: the true nature of consciousness itself. Consciousness is the lens through which we experience the universe. It is the observer that perceives the beauty of the stars, the complexity of life, and the vastness of space. Yet, despite millennia of philosophical contemplation and modern scientific investigation, consciousness remains elusive, intangible, and frustratingly opaque. We know it exists. We feel it in every thought, in every action, in every heartbeat. But how does it emerge? What is its true origin? And most importantly, is it the key to unlocking the deepest mysteries of the universe? In the quantum realm, consciousness plays a peculiar and troubling role. We've seen how particles behave differently when observed, how the act of measurement collapses the wave function and forces the universe into a state of definite reality. This phenomenon, often referred to as the observer effect, suggests that the very act of observing might influence the reality we perceive. But if observation is what creates reality, then who is the ultimate observer? What is the force that shapes our universe, shaping it into something tangible and real, when we, as conscious beings, are no more than fleeting moments in the cosmic timeline? Could it be that consciousness is not just a byproduct of the brain, a product of evolution and biology, but something far more profound, a cosmic force that shapes the very fabric of reality? Could consciousness itself be the architect of the universe, bending the laws of physics to its will, creating not only the perception of reality but reality itself? One of the most disturbing possibilities in modern physics is that consciousness and reality are inextricably intertwined. The act of observation doesn't just influence what we see, it may literally shape what is. In the world of quantum mechanics, particles can exist in multiple states until observed, and the moment they are measured, they collapse into a single reality. This has led some physicists to propose that consciousness itself is a fundamental component of the quantum world, acting as the trigger that collapses the infinite possibilities of the quantum realm into the definite, tangible universe we experience. But if consciousness is the key to creating reality, then we are left with an even more terrifying question. What happens when consciousness is no longer present? As we discussed earlier, the universe is destined to eventually fade into darkness. All the stars will burn out, all the black holes will evaporate, and all matter will disperse into the cold, empty void. If there is no consciousness left to observe, will reality itself cease to exist? This is where the horror of consciousness becomes palpable. If consciousness creates the universe, then without consciousness, the universe has no reason to exist. Could it be that consciousness is the very force that gives existence its meaning, its shape, and its purpose? And if so, when the last conscious observer is gone, will the universe fade into nothingness, its meaning and purpose lost forever? Some theories suggest that consciousness might not be limited to human beings or even living organisms at all. What if consciousness is a universal property, a field that permeates the entire cosmos? If this is true, then perhaps consciousness doesn't die with us. It may persist in some form as the universe's last echo. Could the universe itself be conscious, aware of its own existence, and waiting for the final observer to leave before it collapses into the void? The most unsettling idea, though, is that consciousness may be the universe's ultimate paradox. If consciousness is the key to understanding the universe, then how can we ever truly comprehend it? We are trapped in our own minds, observing and measuring the universe with our limited human perspective, unable to step outside of ourselves to see the full picture. It is like trying to understand the entire ocean while being confined to a tiny drop of water. Our consciousness may be the very lens through which we interpret reality, but it also might be the very thing preventing us from fully understanding it. As we ponder these questions, the true terror emerges. What if consciousness is both the observer and the observed? What if, in some way, the universe is not simply a place for consciousness to exist, but a mechanism created by consciousness itself? Could the very act of perceiving the universe be the force that binds it together, shapes it, and gives it meaning? The more we uncover about quantum mechanics, the more we realize that the boundaries between observer and observed are far blurrier than we ever imagined. The nature of consciousness may hold the answers to the universe's deepest mysteries, but as we seek those answers, we must confront the possibility that we may never be able to fully comprehend them. The more we try to understand consciousness, the more elusive it becomes, slipping through our fingers like the very fabric of space-time itself. And as we seek to uncover the truth about consciousness, we may realize that the answers we find are more terrifying than any of the questions we asked. In the end, the question of consciousness may be the final conundrum, a puzzle we can never truly solve, a mystery that lies at the heart of reality itself. Perhaps it is not for us to understand, but to experience. Perhaps consciousness is the final key that unlocks the universe's deepest secrets, but we may never fully comprehend it until we transcend the very limits of human understanding. And when that happens, we may finally come face to face with the true nature of existence, the nature that consciousness itself has created. As we move closer to understanding the cosmos and the ultimate fate of existence, one thought gnaws at our collective psyche. What if the universe is not a fixed, static thing, but something that actively rewrites its own rules? If reality itself is shaped by consciousness, by observation, and by the forces that drive quantum mechanics, then can the universe change its own laws? Could it bend the very fabric of reality, just as we have seen particles bending the rules of space and time? And if the universe can rewrite its own laws, what does that mean for our understanding of fate, existence, and the very laws that we've always taken for granted? We've explored the inevitability of entropy, the cosmic heat death that awaits us all. But here's the paradox. What if the universe isn't destined to end in a cold, lifeless void, but is actually capable of altering its destiny? If time is malleable, if the fabric of reality is not a fixed thing, but a constantly shifting, evolving system, then could the universe itself decide that it doesn't have to die in entropy? Could the very laws of physics change, shifting the course of its destruction? The implications of this are staggering. For all of our understanding of the universe's fate, we have been assuming that it follows the same set of rules that have governed it for billions of years. The laws of thermodynamics, the expanding universe, and the eventual heat death, all these have been thought of as inevitabilities. But what if the universe isn't so passive, so obedient to its own set of rules? This idea takes us into the realm of cosmic self-regulation. Imagine that, like an organism or a living system, the universe has an innate capacity to correct itself, to restore balance when things go awry. We've seen this idea manifest in the concept of dark energy, that mysterious force accelerating the expansion of the universe. What if dark energy, in its ever-expanding influence, is not just a byproduct of cosmic evolution, but a self-correcting mechanism, ensuring that the universe doesn't collapse into a lifeless, stagnant end? In the far reaches of the cosmos, where entropy should be swallowing everything in its path, there may be pockets of reality that defy the conventional decay. These pockets, perhaps protected by unknown cosmic forces or driven by quantum effects we cannot yet comprehend, may hold the key to understanding how the universe could alter its course. And if these pockets of resistance to entropy exist, what happens when the universe begins to take control of its own fate? One of the most disturbing possibilities comes from the realm of black holes. These cosmic giants, devouring everything in their path, have long been considered the final stages of stellar evolution. But what if black holes are more than just destructive forces? They might be the universe's way of resetting itself. Instead of simply consuming and destroying, could black holes be the catalysts for a new beginning? Could they create new universes, spark new cycles of existence, and reshape the fabric of reality? Some physicists have proposed that black holes might be gateways to new dimensions, or even new universes, born from the collapsing stars that feed them. If this is true, then the ultimate death of our universe might not be the end, but rather the rebirth of something entirely new, a continuation of the cosmic cycle in a different form. The laws of physics we know may not apply in these new realms, and time, space, and reality might operate under entirely different rules. This concept shatters everything we've been taught about the universe's ultimate fate. Instead of a slow, inevitable death, the universe might be preparing for a rebirth. The ultimate entropy could give way to a new order, one that we are only beginning to understand. If black holes are indeed the portals to new universes, then perhaps the end is not the end. Perhaps, after the heat death of our universe, the cosmic wheel will continue to turn, ushering in a new beginning, a new cycle of existence, free from the constraints of the laws that once governed us. The implications of this are profound. What would it mean for us, as conscious beings, to know that our universe might simply be one chapter in an infinite cosmic story? What would it mean for our sense of self, our sense of purpose, if we knew that our lives, our struggles, our very existence could be the precursor to something greater, something far beyond our comprehension? And if this is true, then is our current existence merely a transition phase in the universe's eternal cycle? But this idea raises yet another terrifying possibility. What if we are not part of the universe's grand plan, but simply a fleeting anomaly? If the universe can rewrite its own laws, can correct itself, and can give birth to new realities, then are we nothing more than a temporary aberration in its grand design? Are we destined to live, to thrive, and to die without ever truly understanding the scope of our place in the infinite cycle of cosmic rebirths? This unsettling realization forces us to confront a truth that is as liberating as it is horrifying. The universe does not need us. Our existence, while remarkable, is ultimately just one part of a vast self-regulating system that will continue long after we are gone. Our struggles, our triumphs, and our very civilization might one day be forgotten, just as the stars themselves will burn out and vanish. The universe will continue its dance of creation and destruction, indifferent to our presence, indifferent to our meaning. And yet, in the brief time we have, we must decide what we will leave behind. In the end, the universe will continue on its course, whether we understand it or not, whether we survive it or not. But in this fleeting moment, we have the opportunity to embrace the incredible beauty of existence, to seek understanding, and to find meaning in the face of the great cosmic uncertainty. Perhaps, even if we are but a brief flash in the vastness of time, our search for meaning, our attempt to understand the cosmos, will be enough to leave a mark on the universe, a mark that could echo through the void, even after the last star has burned out. As we stand on the precipice of cosmic knowledge, having explored the deep mysteries of space, time, and consciousness, there is one unsettling realization that cannot be ignored. What happens when the universe becomes too stretched, too diluted to sustain itself? We've talked about the slow death of the stars, the eventual entropy that will rob the cosmos of energy, and the collapse of galaxies into nothingness. But what if the true horror of the universe's end isn't just the extinguishing of stars, but the disintegration of space and time itself? The universe is already expanding at an accelerating rate, a revelation that both fascinates and terrifies cosmologists. The discovery of dark energy has given us insight into the forces that propel this expansion, but it has also raised a terrifying question. What if this expansion continues without end? What happens when the universe expands so much that it spreads beyond the very limits of existence? Consider the nature of the cosmos as a vast web, each point of light, each star, each galaxy, connected by invisible threads of space-time. As the universe expands, these threads stretch thinner and thinner. In the distant future, far beyond the lifetimes of any civilizations, stars will be so far apart that they will become invisible. The light from distant galaxies will never reach us, leaving the universe a dark, cold, and desolate place. But there's an even more terrifying scenario that lies in wait: the possibility that this expansion may tear the very fabric of space-time itself. Imagine a scenario where the expansion continues, faster than anything in our comprehension, until space itself begins to unravel. It is a chilling thought that the very structure of reality could begin to disintegrate. What would it mean for the cosmos if the very dimensions of space and time began to tear apart, as if reality itself was being stretched beyond its breaking point? If this happens, It's not just that stars and galaxies will fade into oblivion. The universe could literally unravel at the seams. This phenomenon, known as the Big Rip, is one of the most terrifying concepts in cosmology. It proposes that the expansion of the universe could accelerate to such an extent that it would overcome the forces holding galaxies, stars, and even atoms together. The gravity that binds our solar system would be overcome, pulling the planets away from each other. The forces that hold galaxies together would be shattered, ripping apart everything in the universe, down to the very atoms themselves. In the final stages of this event, even the fabric of space-time could be torn apart, leaving nothing but a void of infinite expansion. The terrifying prospect of the Big Rip leads to an even darker possibility. Could this unraveling extend to the very laws of physics? If the universe stretches so thin that its fundamental constants lose their grip, could reality itself cease to function as we know it? The laws of thermodynamics, quantum mechanics, and general relativity, the very foundation of our understanding of existence, could break down completely. Imagine a universe where causality itself fails, where cause and effect no longer hold true, where the very notion of time becomes irrelevant. This is not just an abstract theoretical exercise. The mathematics behind the Big Rip suggests that it could happen in a finite time frame, perhaps as soon as 20 billion years from now, or even sooner. As we move into the far future, the universe's fate will become more and more uncertain. The forces that hold everything together, the gravitational pull of galaxies, the electromagnetic forces that hold atoms intact, and even the strong nuclear force that binds particles together, will be gradually overpowered by the expansion. Eventually, there will be nothing left but a stretched-out, fragmented cosmos, where nothing works as it should. And yet, even as we contemplate the terrifying implications of the Big Rip, another unsettling possibility looms. What if the universe has already started this unraveling, and we just don't know it yet? If the universe is expanding at an accelerating rate, what if we are already seeing the first signs of this cosmic disintegration? Could the laws of physics that we rely on, the constants that form the backbone of our scientific understanding, be starting to shift in ways we cannot yet perceive? What happens when the very constants of the universe are no longer constant at all? The discovery of dark energy has already challenged our understanding of gravity and the structure of the universe. But what if this mysterious force is not just pushing the universe apart, but is also eroding the very foundation of reality itself? As space-time stretches thinner and thinner, it's not just the stars that fade away. It could be the rules that govern the universe themselves, slowly breaking down. In the face of this looming cosmic terror, we are left with the most profound of questions. If the universe is slowly unraveling, does that mean everything is ultimately meaningless? If the stars will burn out, the galaxies will drift apart, and the laws of physics will fade into irrelevance, then what is the purpose of our existence? What is the point of striving for knowledge, for meaning, when the universe is doomed to become a cold, empty void? Yet, even in the face of such despair, there is something deeply human in our desire to understand. We are creatures who seek to make sense of the senseless, to find meaning in a cosmos that seems destined to break apart. The very fact that we ask these questions, that we search for understanding in the face of such overwhelming uncertainty, may be what defines us. Even if the universe ends in disintegration, even if everything we know is destined to crumble away, the pursuit of knowledge remains one of our most powerful instincts. Perhaps in the end, the true meaning of our existence is not found in the ultimate outcome of the universe, but in the journey itself. The fact that we, as conscious beings, are here to witness the mysteries of the cosmos, that is the true miracle. Even if the universe unravels, even if time and space lose their grip on reality, we are still given the gift of consciousness, the ability to contemplate the infinite mysteries of existence, even as everything falls apart around us. And as the universe stretches toward its final moments, as the stars fade and the galaxies scatter, we are left with one final terrifying question. What lies beyond the Big Rip? Can anything survive the unraveling of everything, or will we simply be left with a dark, endless void? The ultimate answer may never come, but the search for understanding, the desire to know, will continue, even as the universe fades away. As we journey further into the most unsettling corners of the cosmos, the ultimate horror looms ever closer, the collapse into nothingness. We've examined the slow death of stars, the Big Rip, and the disintegration of reality as we know it. But what happens when the fabric of the universe is stretched beyond repair? When the last particles of existence have drifted into the cold emptiness, what remains? Will the cosmos simply fade away, leaving nothing but a silent, eternal void? Or could this void itself hold its own mystery, a puzzle that even the greatest minds of the universe are yet to unravel? Imagine a time, far beyond the end of the stars, when black holes have evaporated and galaxies have long since drifted apart. The universe, in its final moments, is stretched so thin that even the idea of space and time begins to lose meaning. Nothing remains but the void, an emptiness that stretches across infinity. The final remnants of existence, quarks, photons, and stray particles, are so spread out that the very concept of a singularity becomes irrelevant. The vast expanse that remains is not empty in the conventional sense. Rather, it is an eerie, unsettling absence, a cosmic limbo where nothing happens, and yet everything is still possible. This, perhaps, is the final frontier of understanding, the unimaginable stillness of the universe, when the laws that once governed it no longer apply, and the future stretches endlessly into the unknown. This void, however, is not the end of the story, for in this silence, a deeper question arises. Can the void itself be the cradle of new beginnings? Is there perhaps something hidden in the cosmic emptiness, something waiting to re-emerge once the universe has shed its physical form? We've already speculated that black holes, in their final moments, could be the birthplaces of new universes, but could this ultimate void, this expanse of nothingness, be a precursor to something far more disturbing? What if the void itself is not an end, but a liminal space where the universe can regenerate, where time and space as we know them can break free of their limitations and give birth to a new cosmos? What if, when everything else has collapsed, the very fabric of the universe is reborn, not in the traditional sense, but as something altogether alien, incomprehensible? As we grapple with this thought, we confront the possibility that, despite everything we've witnessed, the death of stars, the collapse of galaxies, the unraveling of space-time, there may still be an overarching order behind all of it. In the same way that quantum particles behave according to laws that seem nonsensical from our macroscopic perspective, could the very end of the universe follow rules beyond our comprehension? Is the void itself a step toward a higher state of existence, one that we can barely begin to understand? Could this final emptiness contain the seeds of rebirth, of something so alien to our senses that it defies everything we know about life, existence, and the cosmos? And here's where the terror deepens. If the universe is indeed destined to collapse into this eerie void, with no stars, no galaxies, and no matter left to anchor it, does that mean the end of meaning itself? If the laws of physics are no longer relevant, if space and time break down entirely, does consciousness cease to exist? What happens to the very essence of being when the last particles of matter, energy, and consciousness are scattered across the infinite void? Are we simply witnessing the death of everything, including ourselves? Or could there be a cosmic logic at play, one we simply cannot grasp? Could the very concept of nothingness be a part of a greater cycle, a process we are not yet equipped to understand? We have spoken of the end of the universe, but perhaps it is only the end of our current understanding of the universe. Perhaps the true fate of the cosmos is not its end, but a transformation into something so fundamentally different that our minds are incapable of conceiving of it. What if the universe, as we know it, does not die, but evolves into a new phase, a phase we cannot yet imagine, where the rules of physics and reality are completely rewritten? This unsettling thought leads us to the final, most terrifying question of all. What happens to consciousness in this ultimate void? If the universe collapses into nothingness, where does our consciousness go? If reality itself is reduced to a blank slate, what happens to the minds that once inhabited it? Are we truly aware of our final moments, or do we simply fade into non-existence, our consciousness scattered like the last remnants of energy in a dying universe? Yet, even in this horror, there is something undeniably fascinating. The void represents the ultimate unknown, a realm where the limits of knowledge are tested to their breaking point. It is a place where the rules of existence are discarded, where the very idea of life and death is irrelevant. And yet, it is also the place where our curiosity is tested to its limits, where our desire to understand the nature of reality is stretched beyond measure. For all the terror the void represents, it also offers us a paradox, the final frontier of discovery. Can we ever truly comprehend the vast, empty void that will one day engulf the universe? Or will we always be left wondering if there is more beyond, something beyond our perception, waiting for us to find it? The cosmic void is both the end and the beginning, the final curtain call for the universe, and perhaps the birthplace of something we cannot yet imagine. As we reach the end of our journey through the cosmos, we are faced with the ultimate truth. The universe is not just a place of creation and destruction. It is a place of constant transformation, of constant potential. And while it may seem that everything is doomed to collapse, there is still the possibility that the void, the final emptiness, is simply the beginning of the next cosmic story. As we reach the final leg of this journey through the deepest corners of cosmology, one question looms over us, chilling in its enormity. What comes after the universe ends? We have explored the expansion of the cosmos, the eventual collapse of stars, the unraveling of space-time itself. We've ventured through quantum paradoxes, where time can bend, particles can exist in multiple states, and consciousness may hold the key to shaping reality. But in the face of all these discoveries, we are left with one profound, unanswerable question that transcends everything we know. Is there truly an end? Or is the end itself part of a never-ending cycle? In the cold, empty void where galaxies no longer exist and time loses its meaning, can we truly say that everything is gone? When we face the slow disintegration of the universe, when entropy takes its toll and everything stretches into nothingness, does that mean the end of existence? Or does it mean something far more terrifying and incomprehensible, that the universe itself is caught in an eternal cycle, a never-ending loop of creation, destruction, and rebirth? This question reaches into the deepest mysteries of the cosmos and our very understanding of time and space. We've talked about the eventual collapse of everything, the heat death, the big rip, and the black holes that consume and scatter. But in the heart of these predictions, the terror arises from one inescapable truth: the universe might not truly end. What if the concepts of beginning and end themselves are nothing more than human constructs? What if the cosmos itself, in its infinite vastness, is part of a cosmic dance that never stops, never truly concludes, and instead endlessly regenerates, cycling through new versions of itself? There's a haunting beauty in this idea, the thought that everything we know, every star we see, every planet we inhabit, is just one chapter in an eternal cycle. It might be impossible for us to truly grasp, but the more we study the universe, the more it becomes clear. The laws of physics, the constants that bind the cosmos together, could be part of a far grander, more intricate pattern than we have ever imagined. Perhaps death and destruction, like birth and creation, are simply phases in a cycle that's constantly repeating, forever chasing its own tail. If the universe's end is not truly an end, but the beginning of a new cycle, then what does that mean for us? Is the final fate of humanity, of all life, of all existence, part of this eternal loop? Are we merely small, fleeting pieces in an infinite cosmic puzzle, destined to be reborn in different forms across untold universes, until the end of time itself becomes meaningless? If this eternal cycle exists, does that give us a sense of comfort? Or does it add another layer of existential dread, knowing that the universe will continue, indifferent to the individual lives it cradles for a fleeting moment? The ancient Greeks spoke of the eternal return, a philosophical concept suggesting that time is cyclical and that the universe is doomed to repeat itself infinitely. Could this ancient idea have a modern cosmic truth? Could the universe be restarting, resetting itself with each cycle, each time it fades into the void, only to emerge once again in a different form? And if that's true, then where does humanity fit into this cosmic game of rebirth? Are we fated to live and die, only to be reincarnated in new forms, new worlds, over and over again? At the heart of this idea lies the ultimate mystery. What happens when the universe ends? If everything is part of a larger, infinitely repeating cycle, then can we truly say that the universe ever truly ends in the conventional sense? The cyclical view of the universe suggests that we may be part of a larger cosmic loop where every death is a new beginning, and the boundaries between creation and destruction are blurred. Could the destruction of the cosmos, the ultimate heat death or big rip, be nothing more than the closing of one door, only for another to swing open, leading to a new beginning, a fresh start for the universe in a form we cannot yet understand? The more we delve into these ideas, the more we realize that the universe, our universe, is far more than we have ever imagined. Its mysteries stretch beyond our comprehension, and the questions we ask only lead us to more complex, unsettling conclusions. Perhaps the greatest mystery of all is not the end of the universe, but the fact that we are here at all. Conscious, questioning, seeking meaning in a vast, infinite cosmos. As we stand at the edge of understanding, looking into the infinite abyss, we are forced to confront the reality that the universe may have no ultimate answer. The end may never come. Time itself may be a loop, and everything we've witnessed, the birth of stars, the formation of galaxies, the rise of life, may just be part of an ongoing cosmic cycle that transcends our understanding of life and death. The greatest horror, then, may not lie in the ultimate collapse of the universe, but in the unsettling realization that we may never truly escape its cycle. We may continue to live and die over and over again, forever caught in the vast, endless web of existence. Or perhaps in the end, we will find that the universe itself has no end, no final moment of peace, and no true conclusion. The universe may simply keep unfolding, expanding, collapsing, and reforming forever and ever. And in that eternal dance, we are but brief, fleeting sparks, searching for meaning in a reality that may never fully reveal itself. But as we stand in awe of the stars, contemplating the grand mysteries of the cosmos, perhaps the ultimate question remains. If the universe has no end and no true beginning, then what is the ultimate purpose of our existence?